prepared to act. An exact knowledge of the signals and what to do when you hear them could save your life. There are 4 warnings. The red, the grey, the black, and the all clear. First, the red warning. This siren is sounding the red warning. It means that there is imminent danger of an attack. This is the grey warning. It means that fallout is expected in an hour's time. Where sirens have not yet been provided, the grey warning may also be given by church bells, or in Scotland, where church bells are not in common use, by word of mouth or by whistle. These are maroons. They indicate the black warning. It means there is imminent danger of fallout in your area. Where maroons have not yet been provided, this warning might be given by a gong or whistle sounding 1 long and 2 short notes, which is the Morse note D. Finally, this is the all clear. It means that there is no further threat of air attack or fallout and that you can leave your place of shelter. The all clear may also be given by civil defense workers or the police. Now, what to do when you hear the signal? First and most important, you should take cover immediately if you hear this red warning. If you are outdoors and cannot get home in 4 or 5 minutes, take cover in the nearest building. If you are caught in the open, take any available shelter. But if there is no obvious cover, you should lie in a ditch or a depression in the ground, covering the exposed skin of your face and hands to protect them from the heat flash.
Here is an emergency announcement. An air attack is approaching this country now. Go to shelter or take cover at once.
If you are driving a car, park immediately. But do not leave your car in any place where it might obstruct the many vehicles that will be engaged on urgent rescue work. Park it off the road if possible. Find the nearest cover, and if there are no buildings, lie flat in a ditch or depression. You should always give shelter to anyone who is caught in the open near your house when the warning sounds. They may have no other protection from the attack.
An air attack is approaching this country now.
If you are visiting, take cover wherever you are, unless you can get home in 4 or 5 minutes. If you are at home, you should turn off the gas and oil supplies and disconnect your electric heaters. Damp down any fires with earth or sand and close all your windows. Then take cover in your fallout room or shelter. Now a grey warning, with fallout expected in an hour's time. If you had only taken temporary cover, you should go home, if you can get there quickly. If, however, you are still in the open, look for safer and more comfortable shelter as quickly as possible. If you are visiting and have taken shelter, go home if you can get there quickly. But if you can't, stay where you are. If you are at home, finish any last-minute preparations and then go to your fallout room. Finally, a black warning, which means fallout is imminent. If you are still outside, find the best available cover. If you are visiting, take shelter where you are. At home, go at once to the fallout room when the black warning is heard. Remain there. Keep the door of the room shut, as there will be plenty of ventilation from around the door. Everyone must realize there is the possibility of an attack taking place before any warning can be given. If this happens, the first indication would be the flash of heat and light produced by the explosion and lasting up to 20 seconds. This would be followed by the blast wave. Whatever happens, you must not look in the direction of the flash. It could blind you. If you are caught in the open by the attack, fling yourself on the ground instantly, wherever you are. Do not move until the blast wave has passed. If you are at home or visiting, move instantly away from open windows or doors and take cover behind the nearest solid protection. When the heat flash passes, go to your fallout room if you can reach it in a matter of seconds before the blast arrives. If you can't, you should stay where you are until the blast wave has passed. It is unlikely that an attack will come without any warning, and the warning system is aimed to give notice of the threat of attack and of fallout so that you have time to take cover. Instant recognition of the warning signals is vitally important. So let's recap. The red warning. Imminent danger of attack. The grey warning. Fallout expected in an hour. The black warning. Danger of fallout imminent. The all clear, no further danger of attack or fallout. Warnings will only be cancelled by the all clear, or by word of mouth from the police or civil defense warden. Once a warning has been given, there is danger, and you must not expose yourself needlessly. From now on, you must listen for and take immediate notice of warning signals. For your own safety, you must follow exactly and promptly any instructions given by civil defense workers or the police. The warning system can save your life. You must not only know what to do in the event of a nuclear attack, you must also know what action to take immediately after. Your safety may depend on prompt action taken during the short time that may elapse before fallout arrives. As soon as the heat and blast waves have passed, one of you should leave your fallout room and find out the extent to which the house has been damaged. Fire will be the most immediate danger. You should go round the house and put out any fires that the heat may have started before they have a chance to become established. Call your family to help you if necessary. Fires can be extinguished by using mains water if still available. You must turn off the stop clock as soon as possible so as to prevent the possibility of contaminated water entering the system. You must at the same time turn off any water heater and shut down your boiler. To prevent valuable clean water from being used for flushing, you should tie up the ball cock in your WC system. From now on, conserve your water supply. Having dealt with the inside of your house, you should now put on gumboots or stout shoes, a coat done up to the neck, a hat or headscarf, and some gloves before going to see what needs to be done outside. This must be done, regardless of the unknown risk of fallout. Make sure your house is safe from any fires which may have started nearby, or fires which may spread from other houses. When you have dealt with your own home, be ready to give assistance to your neighbors if they need help. whatever you are doing, listen for the warning signals of approaching fallout. If you have been in the open after an attack, when you get indoors, take off your outer clothing and leave it outside the fallout room. Have a wash if possible. By these precautions, you will get rid of any fallout that may have settled on you. Once this has been done, go to your fallout room and stay there. It is vital that you should know what to do immediately after a nuclear attack. On your actions may depend the safety of your home, your family, your neighbor, and yourself. Any delay on your part may endanger the lives of everyone living around you. Once the black warning is sounded, it means your home is in a fallout area, and you must remain in your fallout room. Remember, you may have to remain under cover for at least a week, but our general guide to the days you will have to spend in your fallout room.
Stay in your refuge room.
During this period, listen for announcements and instructions on your radio. It will be all right for you to leave the fallout room to collect more food or water, or to go to the lavatory. But time spent outside your fallout room should be kept to the absolute minimum. Except for these reasons, you should never go outside the fallout room. Fallout dust cannot usually be seen. Only the wardens and the police, with their special instruments, will know the level of fallout radiation. The amount of fallout will vary from place to place. It will be heaviest in the middle of the fallout area and grow less and less towards the edge of the plume. Where fallout is particularly heavy, people may have to be moved to a safer area. If this does become necessary, you will be told by radio or by the warden or the police. Keep your suitcase to hand and be ready to move, but on no account leave home before you are told. If you have to be moved, put on some warm clothes and take with you enough food to last for 24 hours. This food should be packed in airtight containers. Private car owners will be asked and expected to fill every available seat. As few people as possible will be moved, and for most of you, it will be stay in your fallout room. Use your food and water carefully, and always remember the danger of radiation. For your own safety, you should wear plastic or rubber gloves. Keep all your food covered. If the cover is unbroken, then the food will be safe. Before you open the food, wipe the packing carefully. This will prevent any fallout dust that has settled on the package from getting into the food. When you have unwrapped the food, you should immediately dispose of the wrapping in the dustbin. Your water must also be kept covered. Do not use any mains water for cooking or drinking until you have been told that it is safe. In the meantime, use your water sparingly and reuse the water for different purposes. Always remember, boiling contaminated water will not make it safe for drinking. Everywhere, the dangers from fallout will decrease as time passes. When the danger from fallout is lessened sufficiently, the civil defense or the police will tell you when you can go outside. Do not go out until you are told it is safe. And even then, you may only be able to go out for a very short time. Essential work will be restarted as soon as possible. Emergency arrangements may be made for the distribution of water. You will be told when it is safe to stay out for longer periods, but there will still be danger from fallout, and nobody should remain outside for longer than necessary. You must still be careful not to bring fallout into the house from outside. Wear some stout boots or shoes to go out, and change before returning indoors. Wash the boots thoroughly when you get back. Wipe down all the working surfaces in your kitchen, your larder, and also anything that may come into contact with boots. You should wear plastic or rubber gloves, and when you have finished, you should wash the gloves. Burn all your rubbish. Although the fire will not get rid of radioactivity, it will reduce the bulk of your rubbish and help to prevent the spread of ordinary disease. If the present world situation does lead to a nuclear attack on this country, it is vital that you shall have taken the necessary measures to safeguard your home as much as possible. It is vital that you should know what action to take in the event of a nuclear attack. If you fail at this, your negligence could endanger the lives of your friends and neighbors as well as your own family. Remember that the civil defense wardens and the police are here to aid and advise you, but wherever you live, you must know how to help yourself and be prepared to help others if their lives are in danger.
Nuclear explosions are caused by weapons such as H-bombs or atom bombs. They are like ordinary explosions, only many times more powerful. They cause great heat and blast. They also make a cloud of deadly dust which falls slowly to the ground. This is what is called fallout. So these are the two dangers. First, heat and blast, which is followed by fallout. The heat and blast is so severe that it can kill and can destroy buildings for up to 5 miles from the explosion. Fallout is dust that is sucked up from the ground by the explosion. It can be deadly dangerous. It rises high in the air and can be carried by winds for hundreds of miles before falling to the ground. You can protect yourself and your family, and later on we will show you what steps to take. Attacked by nuclear weapons, these are the warning sounds you must recognize. First, the attack warning. If an attack is expected, the sirens will sound a rising and falling note like this. Next, the fallout warning. When fallout is expected, you will hear 3 bangs in short succession. They will be sounded by means of maroons like this. Or you may hear 3 gongs like this. Or 3 whistles like this. These all mean that fallout is expected. Warnings of the attack and of fallout will also be broadcast. When the immediate danger of air attack or fallout has passed, the siren will sound a steady note like this. Here are the warning sounds again. Attack. Here is a reminder of what the air attack warning sounds like. This is the sound. When you hear the attack warning, you and your family must take cover at once. Do not stay out of doors. If you are caught in the open, lie down. And now here is a reminder about fallout warnings. When fallout is expected, you will hear 3 bangs in short succession, like this. In some areas, the warning may be given by means of 3 gongs, like this. Or you may hear 3 whistles, like this. All these 3 types of sounds indicate that fallout is expected. When you hear them, you must stay in the safest position in the house. Keep the doors shut. Do not go outside the house until you are told it is safe. Here is the all clear warning. When you hear this sound, you can leave your cover. But keep listening for further warnings. You must now choose a room in your home which will give the best protection from fallout. If you live in a house, the safest place is the ground floor or basement. Choose a room with the smallest amount of outside wall. The farther you are from outside walls and the roof, the better the protection. If you live in a block of flats, which is more than 5 floors high, it is important not to use the top 2 floors. The safest places are inside passages away from outside walls and windows. If the block is 4 floors or less, the best place for a fallout room is the basement or ground floor. If you live too high up to be safe, you must make arrangements now with your neighbors in the lower floors, or make some suitable arrangements to shelter with someone close by. If you live in a one-story house, like bungalow or pre-flat, the building itself will not give you much protection. So the best thing is to make arrangements now to shelter with someone close by. If this is not possible, look for a space in your home which is farthest from the roof and the outside walls. Later, we shall be telling you how to strengthen and improve your fallout room. Choose a fallout room in your home. The best place is farthest away from the roof and outside walls. Your fallout room will protect you, but you will make it even safer by strengthening a small part. This part will be your inner refuge during the worst of the attack. Making a refuge is not difficult. The main things you will need are shovels, boxes, cartons or large plastic bags, earth or sand. Start collecting them now. These things may also come in handy. Hammer, saw, screwdriver, nails, screws, string or thin rope, scissors or penknife. One idea is to make a lean-to of wood, resting against an inside wall. Strong boards or doors taken from their hinges are quite good. Stop them slipping down the wall by fixing them to the floor with a strip of wood, like this. Then cover the wood with bags or boxes filled with some heavy material, like sand, earth, books, or rolled up clothes. Don't forget to fix the bags and boxes so that they don't slip off. Across the two open ends of your refuge, you should make thick walls of bags and boxes of earth or sand, or heavy furniture packed tightly with heavy material. Don't forget to leave an easy way into and out of your refuge. Next, a cupboard under the stairs. That is another good place for a refuge. Put boxes of earth or sand on the stairs and along the walls of the cupboard, like this. If the stairs are on an outside wall, make the wall thicker with bags of earth or sand. Stack the bags up to a height of about 6 feet. Here is another idea. Use tables, if they are strong and large enough for you and your family to shelter beneath. Make solid sides around the tables out of heavy furniture, boxes filled with sand, earth, or wood. You can lay strong boards or doors across the top and cover them with bags of heavy material. This will make a good roof over your refuge. If you live in a caravan or other building of lightweight construction, which provides you with very little protection against fallout, your local authority will be able to advise you on what to do. Whatever type of refuge you have, the main thing to remember is that the more heavy material you have around you, like earth or sand, the more chance there is of safety. Start looking now for materials for your fallout room and inner rescue. Here is a list of things and some ideas for you. Bricks, concrete blocks, bags or boxes filled with earth or sand. If you cannot get hold of sandbags or boxes, try travel bags, haversacks, suitcases, pillowcases, or anything which will hold sand or earth. Strong pieces of wood, heavy furniture, doors taken off their hinges. All these things can give you good protection. Think about them and make plans now. Decide what you already have in your home that will be suitable for making a refuge. Decide what you may need to bring into the house: earth, bricks, sand, etc., to strengthen it. Decide where you will store all these materials, so that you will know exactly where they are when you need them. You can use these materials like this for thickening the floor above your fallout room, for building your inner refuge, for blocking windows, doors, halls, or passages, for thickening outside walls. All these materials can save your life. By now have chosen your fallout room and gathered your materials for an inner refuge. The time has now come to make everything ready for you and your family in case an air attack happens. This does not mean that war is bound to come, but there is a risk of this, and we must all be prepared for it. So don't waste time. Start now. To help you, we will remind you once again about choosing a fallout room and an inner refuge. First, choosing a fallout room. That should be a room in your house which will give you the best possible protection from fallout. A room that is farthest from the outside walls in the room, or one with the smallest amount of outside wall is safest. Whatever room you choose, remember that the further you can get away from radioactive dust in or around your home, the safer you will be. So in a house, the safest place is in the ground floor or basement. In a block of flats, do not shelter in the top 2 floors if the block is 5 floors high or more. Go to the lower floors, ground floor or basement. The central corridors will give good protection. If you live in a bungalow or similar one-story home, it will not give you much protection. If you cannot make alternative arrangements, choose the safest place, which is the space farthest from the roof and outside walls. And now a reminder about your inner refuge. We have told you that your fallout room should be the safest place in your home. Even this is sometimes not safe enough, however, particularly for the first 2 days and nights after an attack, when the danger from radiation could be critical. So you need, inside your fallout room, an inner refuge. A fortified area to give you greater protection during the worst of the attack. The inner refuge should be thickly lined with dense materials to resist radiation, away from outside walls if possible. Now for its construction. Make a lean-to with wood, resting against an inside wall. Use boards or doors taken from their hinges. Stop them slipping down the wall by nailing a strip of wood to the floor like this. Cover them with dense material. and fix some rope around it so that it won't slip. Partly close the open ends, leaving an easy way in and out of your refuge like this. Another good place for a refuge is a cupboard under the stairs. Reinforce the stairs and the side like this. If the stairs are on an outside wall, stack up containers of earth or sand to make the wall thicker to resist radiation. If you've got tables large enough to give you and your family sufficient shelter, use them. Make the sides solid with heavy furniture or boxes of books or sand. Reinforce the top with strong boards or doors and cover them with dense materials. More details are given in the booklet, Protect and Survive. If you haven't got one yet, get one from the post office now. And start right away making your home and your family as safe as possible from nuclear attack. Start now on your fallout room and in a refuge. Thicken the floor above your fallout room. Start blocking windows, doors, halls, passages. Thicken the outside wall of your fallout room. Fallout dust gives off dangerous radiation. It cannot be seen or felt. It has no smell. Anybody staying within reach of fallout for too long can fall ill or die. So you must keep away from fallout until it is safe. This may mean staying in your fallout room for up to 14 days. Prepare yourself for this now by storing water features. Put them in your fallout room or stacked up within easy reach close by. Here is a list of the most important things you will need. Drinking water. Food, mostly in tins. Portable radio and spare batteries. Tin opener, bottle opener, some cutlery and crockery. Warm clothing. And now here is a list of some things which will make living in your fallout room much more comfortable. Bedding, sleeping bags, portable stove and fuel, saucepans for boiling water and cooking, torches with spare bulbs and batteries, candles, matches, table and chairs, toilet articles, soap, toilet rolls, change of clothing, first aid kit, household medicines and prescribed medicines, box of dry sand, cloths or tissues for wiping plates and utensils, notebook and pencil for messages, brushes, shovel and cleaning materials, rubber or plastic gloves. Toys for children, books and magazines to pass the time. Clock and calendar. Finally, don't forget your booklet, Protect and Survive. It tells you how to make your home and family as safe as possible. All the items we've just told you about are listed in it. A may come quite unexpectedly. We will now tell you what to do if a warning sounds when you are at home, and then we will explain what to do if you are outdoors. First, if you are at home. If attack is imminent, you will hear the attack sound like this. So take cover at once. Send your young children to the fallout room, then go quickly and turn off the gas and the electricity at the mains. Close down stove. Damp down fires. Shut windows. And draw curtains. Then go to your fallout room and stay there. If the fallout warning sounds are heard, they will be like these. You should now move yourself and your family to the safest area in your fallout room. That is, you should get inside your inner refuge and stay there. After 2 days, the danger from fallout will get less, but don't take any risks by contact with it. The longer you stay in your refuge, the better it will be for you. Listen to your radio. Stay where you are and keep listening to your radio. Now, this is what you should do if you are out of doors when the warning sounds. Take cover at once when you hear the attack sound. If you cannot reach home in 10 minutes, take cover in the nearest building. If there is no building nearby, try to find some solid cover. If there is no solid cover, lie flat in a ditch or a hole and cover your head, face and hands as fast as you can with some of your clothes. If you hear the fallout warning, seek the nearest and best cover as quickly as you can. But before entering the building or cover, brush or shake off any fallout dust you may have picked up and get rid of it. Change your outer clothing if you can. Stay under cover. When the all clear sounds, like this, it means that you are safe from attack or fallout for the time being, and that you can go out again. But keep listening for further warnings, or to your radio for further advice. After an attack, you may have to stay in your home for about 14 days. So make sure to store plenty of water and food for your family. Water is more essential to life than food. You can live for a long time with a little food if you have enough water or liquids to drink. How much is enough? Well, each person should drink about 2 pints a day. So, for 14 days, 3.5 gallons is enough for one person. but you should double this amount if you can. Then there will be some to spare for washing your face and hands. Keep drinking water in your fallout room. Store it in plastic containers with a screw top, or in bottles or jars covered to keep out dirt. Store the rest in kettles and saucepans and in basins in the bathtub. Try to keep some tins of fruit juice as well. Now, food. Stock enough for everybody for 14 days. You may not be able to cook anything hot, so buy food you can eat cold and that will not go bad. Buy food well wrapped or in tins. By the way, don't forget your tin opener and bottle opener. You will do best to buy lots of different kinds of foods if you can, so that you won't get bored with too much of the same thing. Stock up with meats, vegetables, fruit, tinned or powdered milk, and special foods for babies or infants. You will also need some sweet foods, like sugar or jam, and biscuits. Keep the food in a cool, dry place until you have to take it to your fallout room. Foods that will go bad quickly should be the first to be eaten. Try to ration everything so that it will last out. A nuclear explosion produces intense heat. This can get through unprotected windows and set fire to things in your home. But there are steps you can take now to cut down the risk. First, whiten your windows with white paint to reflect some of the heat away. This will cut down the risk of these fires. Then get rid of junk lying about in your attics and upper floors, especially old papers and magazines, which can catch fire easily. The heat from the bomb strikes at attics and upper floors most easily, and fires there are usually the hardest to put out, so pay particular attention to these places. In other parts of the building, clear away papers and magazines. Then net curtains from windows. And any old rubbish inside or outside your home which is likely to catch fire easily. Small fires can be put out easily if they are tackled at once. If they are left, they spread fast and soon get out of control. The fire brigade may not be able to reach you, and you will have to protect yourself without any help. So prepare now. If you have a fire extinguisher, keep it handy. Or a garden hose could be very useful. Keep buckets of sand and water ready on each floor. When you take cover in your inner refuge, you must not go outside until it is absolutely safe. And if the fallout is heavy, you may be in your refuge for quite a long time. Although the danger from fallout will get less and less as time goes by, you will never be able to judge for yourself how bad it is. Advice will be given to you on the radio, so keep listening. This advice over the radio and other instructions and news will be very important to you while you're cut off from the people living around you. So make sure your radio is in good working order. And if you have a spare radio, keep it in your fallout room. Radios must be battery operated because your electricity may be cut off. so be sure to get some spare batteries. After a fallout warning, you have been advised to take cover in your inner refuge. The first 2 days will be the most dangerous period because fallout will be at its worst. So it is in your best interest to stay in your inner refuge the whole of that time, however cramped or uncomfortable it may be. But if you must leave the refuge to go to the lavatory or to get more water or food, don't stay out a second longer than is necessary. In any case, don't go outside the fallout room at all. After 2 days, the danger from fallout will be less, but it may still kill you. So the longer you stay in your inner refuge, the better your chances are. Although it may be fairly safe for you to move about inside your fallout room, it certainly will not be safe for you to go outside the house until the radio tells you. So keep listening to your radio for advice. At first, you'll be told when you can go outside the house for a short time to get rid of lavatory waste and rubbish. Then, as the danger from fallout begins to pass away, you will be able to stay out for longer spells. There may still be a lot of fallout dust lying about, so be careful not to bring it back with you into the house. Keep a separate pair of boots or strong shoes for going out. Before coming in, take them off and wash or wipe them, soles as well. It is also a good idea to wear rubber gloves while you are outside. Try to keep the younger people indoors as much as possible. In fact, it will be far wiser for only people over 30 to work outside until things get better. And now a reminder of some of the things we have told you in earlier films. Fallout can kill, though you cannot see it, feel it, or smell it. There is danger outside, so don't go outside. Stay in your fallout room until you are told it is safe to come out. After an attack, fires will start in many places. The fire brigade may not be able to help everyone, so it might be up to us to tackle the fires in our own homes. Here is some advice on how to do it. Make sure that you have turned off gas and electricity at the mains. Don't smoke. Then start checking for fires. Start at the top of the house. Check roof space and every room, putting out fires before they get out of control. Small fires can be put out much easily if they're tackled at once. If they are left, they spread quickly and take hold. Use water from the tap if there is any. Earth and sand are also useful. Put all the members of your family to work putting out fires in the house. When you are satisfied that the inside is safe, check the outside of the house and make sure that you are safe from any fires which have started nearby. When you have seen to your own household, help any neighbor in need. If you have used any of your precious drinking water to fight fires, make good your reserves. Fill up all your containers again and put covers on them. Turn off your water supply at the mains. It may become contaminated. If your house is damaged, you may have a little time before a fallout warning to carry out minor jobs to keep the weather out. Curtains or sheets may be used to cover broken windows or holes. Then listen for the fallout warning. If it comes, take cover in your inner refuge and stay there. Earlier we told you what to do to prepare emergency lavatory arrangements in or near your fallout zone. It will not be easy for you to keep clean in shelter conditions, mainly because it is unlikely that there will be any water to spare for washing or for flushing the lavatory. But cleanliness is essential to prevent sickness, and here are a few simple rules to help you. All toilet containers should be covered when they're not in use. Pour in some disinfectant. It will cut down the smells and keep off flies. When you have used the bucket lavatory, wipe your hands with toilet paper soaked in a little mild disinfectant. Throw the paper into the container and put the lid on. Keep an eye on small children and see that they do the same as you to keep clean. Don't let the bucket get too full. If you have lined it with a plastic bag, tie the neck tight before lifting it up. And put it in a separate dustbin well away from the fallout room. Put a fresh plastic bag into the bucket with a few drops of disinfectant. Cover the bucket with a lid. When it is safe to do so, take the dustbin and its contents outside the house. Remove the waste and bring the empty bin back. Food scraps, empty tins and other rubbish should be wrapped up tightly in newspapers and put in a separate dustbin. Keep the lid on. If you have got only one dustbin, use that for toilet waste only. Put all other rubbish separate in plastic bags or paper until you can take it outside the house. Keep your hands as clean as possible. Wear rubber gloves for dirty work. Try to avoid touching food with your hands as much as possible. Keep your knives and forks, plates and cups, etc. clean. Dry, clean sand is quite good for this. After an air attack, your water taps may run dry, or the water in them may be too dangerous to drink because it has been poisoned by water. So your life may depend entirely on what you have stored. Keep it clean by covering the containers. Its main use is for drinking, but use it sparingly. For each person, you should have stored at least 2 pints for each day. Don't waste water on washing or anything else. If you must use water for cooking, use as little as possible. If you heat cans of food in a saucepan of water, don't throw the water away. It can be used over and over again. By the way, make sure you pierce the top of the can before heating. Dip your dirty knives and forks into the pan while the water is still hot. Water is life. Save it. Should by now have built up an emergency reserve of tinned food or other foods that don't go off quickly and that can be eaten cold. Keep your food reserves in your fallout room. And remember to keep them well covered to protect them from fallout dust. There might be fallout dust on the packaging. Take care this does not get into the food. So wipe the tins, packets, and bottles. You may not be able to replace your stocks of food for a long time, so make them last. Most of the time, you'll be resting in your fallout room, and you won't need to consume much food. Eat the smallest amount you can get by with, and plan meals carefully so that there is no waste. And remember, keep your food covered from fallout. Wrap open tins and loose foods. Prepare small amounts at a time. You may not be able to replace your stocks for a long time, so ration food carefully. After an attack is over and the all clear has been sounded, arrangements will be made as soon as possible to treat any people who are ill or injured. Listen to your radio. Details will be given about what to do, when to do it, and how. If anyone dies while you are kept in your fallout room, move the body to another room in the house. Label the body with name and address, and cover it as tightly as possible in polythene, paper, sheets, or blankets. Tie a second card to the cover. The radio will advise you what to do about taking the body away for burial. If, however, you have had a body in the house for more than 5 days, and if it is safe to go outside, then you should bury the body for the time being in a trench or cover it with earth and mark the spot of the burial.
million suns. Each star, like our own sun, is a raging nuclear furnace. It shoots out showers of particles too tiny to be matter as we can see, along with invisible forces which we call radiation. This radiation and these particles travel through space at fantastic speed until they strike some other matter which may make new flares of radioactivity. They strike wandering asteroids, moons, and planets such as our own. Everything in space, Earth included, receives. We don't worry about the small amounts of natural background radiation. But to safely handle larger amounts, we must keep our distance and shield ourselves. Or, as the amounts increase, so do the dangers. The amount of energy generated by a nuclear explosion is enormous. Atoms produced in the explosion join with the particles of Earth's debris. Millions of highly radioactive particles of matter that we call fallout. The strong winds of the upper altitudes go to work on the clouds, blowing them off in one or more directions. Gravity tugs on the particles. The larger and heavier ones sink toward the ground, while the lighter particles continue to drift with the wind. Some of the lightest particles remain suspended in the upper atmosphere. As time passes, their radioactivity grows weaker, so that the longer they remain aloft, the less dangerous they are. But the heavier particles, spread by high-altitude winds, fall to the ground within 24 hours. Several miles from the explosion, they are about the size of table salt or fine sand. These are the most dangerous, because they carry the greatest number of radioactive atoms, and so emit the largest amount of nuclear radiation. Brings us to an all-important fact. Deadly as radiation can be, as important as weakness, a rapid rate of decay. And this gives us an invaluable ally, time. Suppose a nuclear explosion takes place at 12 noon. By 1 o'clock, the total force of the residual radiation is at a high level. By 7 o'clock, it's down to 1/10. In 2 days, although still dangerous, it's only 1/100th. But in 2 weeks, it's only 1/1000th. With this decay rate in mind, consider radioactive fallout conditions which might confront us after a massive attack. Within an hour, fallout will be a serious problem in the vicinity of explosions which occur on or near the ground. By 7 hours after the attack, the fallout area covers more and more of the country as the prevailing winds expand the fallout in a downwind pattern. 24 hours. 48 hours. Without shelter, millions would face death. A few days later, those who have taken shelter will survive. In many areas, people can even leave shelter for brief periods of time to carry out important tasks. Within 2 weeks, most people can leave their shelters for longer periods as the radioactivity decays to lower levels. The lesson is obvious. We must shield ourselves from radiation through the dangerous periods. To do this, we need more than time. Fortunately, we have another ally. Distance. The greater our distance from the fallout particles, the less radiation we receive. You would receive less radiation in the middle of a tall building cover the roof and the ground around the building. Only an insignificant amount would get inside. And finally, along with decay rate and distance, we have still another and very important ally. Mass. When highly radioactive fallout covers our immediate area, we shield ourselves through the most dangerous period by using the sheer weight of any material. But the protecting material must be heavy. To shield out some 99% of the radiation, you would need about 5.5 feet of wood, or 2 feet of earth, or 1 1/3 feet of concrete, or a half foot of steel. Even though the thickness of these materials varies, they all weigh the same. Taking a house as an example, it offers a small amount of mass and distance from radiation, but not enough protection in an area of heavy fallout. The solution is plain. Fallout shelters are the best defense against nuclear radiation, whether in a home for a single family or a large community like in an apartment building. They offer the kind of protection from radiation you would probably need in case of a nuclear attack. But the best shelter would be worthless unless it was used. Most people find it hard to understand how silent, invisible rays, which cannot even be felt, can be so damaging. Let's see what happens when radiation penetrates the body and attacks the cells. What is a cell, and what happens when it is attacked? It's a simple organism, which reproduces itself by dividing. Our bodies are... The key then is the amount, the total dose of radiation received. We measure radiation in the same way speed is measured by a speedometer. Only instead of a speedometer, we have a rate. And instead of miles per hour, we measure the rate in recipe per hour. We need another device, called a dosimeter, to record how much radiation a person has accumulated over a period of time. In the same way, we record accumulated distance in miles. The dosimeter records accumulated dose in length. With this in mind, let's return to background radiation. In an average lifetime, a person might expect to accumulate about 10 Roentgens from his natural environment. Not enough to affect his health. This same healthy person would need medical care if he received more than 200 Roentgens within a few days. 300 Roentgens in the same period would cause severe radiation sickness or possibly death. And as we go beyond 300 Roentgens, the danger of death increases rapidly. So now we see why shelter is vital. The difference between accumulating a large dose because of little or no shielding and a small dose because of adequate shielding is the difference between death and life. No clothing, of course, can possibly provide enough shielding. However, if you were to be in the open during fallout conditions, clothing would keep the particles from touching your skin. There is no such thing as a fallout suit, but ordinary clothing would help until you could reach the safety of the shelter. Then the fallout particles can be brushed off and outer clothing removed. If fallout settles on your food, the food itself is not harmed, since radiation damages only living tissues. And you can easily decontaminate it using almost the same method you use in everyday food preparation. Actually, even if you accidentally swallow some fallout particles, secondary damage, it's wise to remove the radioactive particles by simply washing, wiping, or peeling. But it's vital to remember this. Neither water nor chemicals can destroy radioactivity. The fallout particles can only be moved or washed away. Only time can reduce their potency. And what of water? Well, here again, the same rules apply. If necessary, you could drink water containing fallout particles without worry or immediate harm. The chances are you wouldn't have to for long. But water helps to wash itself through the natural processes of sedimentation and filtration. And swiftly moving rivers like this would carry most fallout particles downstream. In still waters, most particles would settle quickly to the bottom. Others might remain suspended in the water for a long time, while a small percent of the radioactivity would dissolve. The normal processing of a water treatment plant would make it safe to drink. And water coming from a covered well would be safe from radioactive contamination. There is no problem with breathing, for air is not contaminated once the fallout is on the ground. Fallout is not a poison gas. If ventilation is needed in a shelter, a simple inverted tube fitting on a ventilating pipe will keep fallout particles from entering the pipe and getting inside. Of course, surviving a nuclear attack means more than just waiting in a shelter for radioactivity to decay to safe levels. Survival, reconstruction, and recovery would involve decontamination in many areas. A very difficult job.
Unit 8 at Elman Mark. Dose rate 15 Roentgens per hour.
Fallout would have to be removed from important areas by street sweepers. And the remaining particles could be flushed out of the way. Food would be a problem. After a nuclear attack, we would first use existing food supplies from shelters, markets, and surplus food stores. When fallout had decayed to safe levels, people could begin to work in the fields for limited periods of time. In a few areas, the land would not be suitable for food, but such crops as cotton could be grown. Crops for human consumption would be grown in areas that had received the least fallout. The reason we would be able to grow and eat food planted in this land is that the transfer of radioactivity from soil to plant is extremely low. So if nuclear attacks should ever come, in spite of every effort to avoid it, we must be able to survive and rebuild for the future. But survival can only come through knowledge. The basic facts you must all know are relatively simple. First, there is nothing new about radiation. It has always been with us. What is new is the vast amount we will be exposed to as a result of nuclear explosion. Much of this danger would come to us in the form of fallout. But we are not without personal weapons or defense. One of these is time. Radiation decays, and so we would would not have to take maximum precautions indefinitely. Another defense is distance. Radiating particles 50 feet away, for instance, would not affect us as much as particles a few feet away. And our third defense is mass. Any material with enough weight will keep the penetrating radius perfect. The greater the weight of the material between us and the particles, the safer we will be. The best way we can use all three weapons of defense is with an adequate shelter, thick enough to shield off a good part of the radiation until it has decayed to safer levels. When radiation attacks, the cells of our body are damaged. Most often can repair themselves if the total dose over a period of time is not too high. Even though the rays penetrate our bodies, causing damage, they do not infect us and make us, or anything else, radioactive. That's why food remains good no matter how much radiation has passed through. Fallout accidentally swallowed with water or food will do you no immediate harm. But for long-term safety, it's best to wash, wipe, or peel the food and filter the water. Even if you were caught outside under fallout conditions, ordinary clothing would keep the radioactive particles from touching your skin. But you would still need to find shelter places. If we remember these factors, we act on them intelligently. We can increase our chances of surviving nuclear attack. And the key to survival is adequate shelter. That is why the federal government has a nationwide fallout shelter program. The goal is adequate fallout shelter space for every man, woman, and child. And this goal can be reached. For with knowledge of radiation, we can face the facts about fallout, take action to protect ourselves, and learn how to live in the nuclear age.
detonation has taken place several hundred miles from this field. Dangerous radioactive fallout is being carried downwind toward the earth. This is one of several public fallout shelters in the town that the Clean Shelter Manager owns. Donald Barnes attended a shelter management course given by an instructor who has received federally sponsored training. Barnes knows the importance of prompt organization within the shelter for the welfare of the population. In this shelter, each person is informed to indicate the coordinator about the occupant. The form provides a ready means to determine the skills and capabilities of the occupant, which may be used in the various shelter functions. Not all shelters will be organized or operated in the same manner. Procedures will depend on the size of the shelter, its floor plan, facilities, supplies, and the availability of trained personnel. Where the number of occupants is large enough, a supervisor for each shelter function may be needed. Members of the community who have prepared themselves with training in civil defense adult education courses, or in such areas as disaster aid or medical self-help, can provide valuable guidance in the shelter situation. Outright Lenore cases have been on shelter training boards to make the best cost home nursing care. In the absence of professional medical personnel, Manager Barnes assigns her the job of nurse. A section has been set aside of first aid. The station will check the medical supplies and arrange facilities for care of the sick. Construction worker and former military policeman holds the assignment of security and control, a necessary function in any situation where many people are confined in a limited area for a length of time. Seeking solace in this time of trial, office worker Bert Gaines finds in himself a native ability to comfort others, to bring them spiritual guidance and hope. The alert shelter manager is always on the watch for the emergent leader who can help to ease the burden of shelter living. Gaines is asked to serve as religious counsel. Harry Wilson, the cashier at the supermarket, is put in charge of vital food and water supplies. Mrs. Wilson will keep a careful check on these provisions, their handling, and distribution. This includes those provisions furnished by the federal government in shelters which meet certain basic requirements. In many shelters, these include only provisions. Other assignments are made to complete the supervision of these shelter functions. The first meal in the shelter. To facilitate the procedure, the shelter population is grouped into units, each with its own leader selected from the occupants, who keep the record of the rations issued to the people in his unit. Water is stored on the basis of 3.5 gallons per person. Federal rations provide 10,000 calories per person. Additional food items may be added to shelter provisions by the community. These might include special foods for persons with dietary needs, utensils for cooking and washing, and additional water rations for cleaning. confident from the beginning that he is to do his job efficiently. He discusses with them the shelter's staff and organization, the facilities available, operating procedures, the daily shift. He emphasizes their dependence on one another in the shelter situation and the need for a helping hand. Questions are asked and answers as quickly as possible. No attention is paid to height. The shelter members use their own discretion in
also progressive. But along the way, times result in dangerous changes in our environment. Unchecked, these changes may threaten our very survival. Man must stop his mishandling of nature and work toward a future with clean air to breathe, clean water to drink, uncontaminated soil in which to grow the food he needs. Oxygen producers like these, vital to our environment, must be protected. This is our deep commitment to the future. How do we meet it? The science of the peaceful uses of atomic energy is one of the ways man is responding in the fight to preserve and restore his environment. The Atomic Energy Commission, from its inception, has had a vigorous program in environmental research. The application of atomic energy to meet environmental objectives moves in two directions. First, supplementing the conventional power plants that pollute the atmosphere with clean atomic power stations. Secondly, use the atom as a research tool to study our environment, especially the burdens placed on the environment by modern industry. This challenging work offers many exciting career possibilities for scientists and technicians. Power production is one example. Electric power requirements in this country have been doubling about every 10 years. Sometimes the heavy demand exceeds supply, causing power blackouts and brownouts. The basic principle of power production is simple. A heat source generates steam, which turns a turbo generator. The heat source may be coal, gas, or oil, called the fossil fuel. But there is another heat source, the atom, the nuclear fissioning of uranium. The discharge of noxious chemicals into the atmosphere is one thing coal and oil-burning power plants have in common. Atomic power plants, on the other hand, don't release smoke containing such contaminants that pollute the atmosphere. Both conventional and atomic power plants discharge some excess heat into adjacent waterways. These thermal effects must be controlled and minimized. Methods are being developed, such as giant cooling towers and man-made lakes. Whatever the heat source, water is converted to steam, which turns the turbine, which drives the generator. When the steam leaves the turbine, it must be cooled and condensed back to water to return to the boiler. The cooling water does not make contact with the radioactive core. Cool water is usually taken from rivers, lakes, or the ocean. At atomic power plants, the water is pumped through the condenser and returned to its source as warmer water. Although so far, no significant detrimental effects of warm water on fish and other aquatic life have been found in the vicinity of nuclear power plants, thorough investigation will continue in order to assure that environmental impact will not be excessive when weighed against man's growing need for electricity. But of course, slightly warmer water may be used beneficially for agriculture and even recreational purposes. Future, more efficient nuclear generating stations, such as the breeder, will release less heat per kilowatt. However, nuclear power plants do release very minute quantities of radioactivity with cooling water into the atmosphere. But federal standards carefully and conservatively regulate such releases to protect the public. In actual practice, the amount of radioactivity released is held to only a very tiny percentage of the amount permitted by the standards. The natural background radiation you would receive from taking a plane ride across the country or from spending a summer in the mountains would be about the same as you would receive receive if you live next door to an atomic power plant for an entire year. One of the reasons for the success of our agriculture was the use of insecticides, resulting in more abundant crops due to the elimination of pests. But unfortunately, insecticides can be harmful to livestock and wildlife. However, insect control is a necessity. Control by using atomic energy as a research tool. Experiments are underway at a number of universities to develop insecticides which will do their job without causing side effects that harm the food chain from plant, animal, to man. At the University of California in Riverside, the Department of Entomology is doing decisive research work in this area under the guidance of scientists such as Dr. Roy Makuto. The purpose of these scientists is to aid in the development of insecticides which are selectively active. To put it simply, the goal is the creation of insecticides that control pests but do not harm humans or livestock. Well, how does nuclear energy come into the picture? Radioactive carbon is the research tool that traces the effectiveness of the insecticide being tested. 2 samples of insecticides are being tested. Sample A, used as a control, is a compound currently on the market. It is poisonous to warm-blooded animals. The new compound B is selectively toxic to insects, and therefore may be used without harmful effects to our environment. Both samples were previously tagged with radioactive carbon. The presence of radioactivity is detected with a radiation counter. The bottle caps have to be removed to obtain a measurable radiation count. Here we see some highlights of the experiment. This mouse is fed with compound A, currently used toxic insecticide, and placed inside a metabolism chamber. A second mouse is given a sample of compound B, the new insecticide. The mouse is put into another metabolism chamber. The test animals spend predetermined time periods in the metabolism chambers. At certain intervals, urine specimens of the 2 test animals are taken to determine the relative metabolizing action of samples A and B by the test animals. Specimens are placed into this radiation counter to measure the radioactivity. Now a tiny amount of both samples is placed on this chromatography plate. The compounds will move to different places on this plate. The position will indicate the nature of the compound. The slight radioactivity of the compound makes it possible to trace them on a photographic film for easy visibility. Thus, atomic energy, through the position of the spots, helps the chemist reach the conclusion that compound B, the new insecticide, is indeed less dangerous to warm-blooded animals than the sample taken from the currently used insecticide. Although it is illegal to dump oil into coastal waters, some ships still flush out their fuel tanks, discharging oil into coastal regions, usually at night. As a result, oil slicks may be washed up on beaches, destroy marine life, and even cause fires. Since our bodies of water are already burdened with more waste material than they can manage, the Coast Guard has added another duty to its routine patrol: protection of the marine environment. When an oil slick is located by the helicopter, a Coast Guard cutter is dispatched to take samples. Scientists using atomic techniques established by a novel use of atomic energy called neutron activation analysis, which produces atomic fingerprints of the samples under investigation. A small nuclear reactor is used for the next step. The oil samples scooped in the ocean, as well as the samples collected from the suspect ships, are made radioactive. Then, a radiation counter is used to produce a profile of each radioactive sample. The information is also recorded on a printout. The atomic fingerprints are compared. In the event that an oil sample from the suspected ship matches one of the oil samples retrieved from the ocean, the authorities can be reasonably sure who caused the pollution, and existing laws can be enforced. Wave energy, strong ocean currents often cause beaches and sandbars to appear to disappear. Beach erosion is a constant threat to recreation areas and homes near the sea, and sand eventually clogs channels. In some cases, constant, expensive dredging is required to clear harbors and channels for shipping. In order to learn more about the mysterious movements of the sand, and perhaps help prevent our valuable beaches from eroding, the Atomic Energy Commission, working during Research Center and Oak Ridge National Laboratory, is studying how the pounding of the waves and currents above affects the movements of the sand below. These boxes contain sand tagged with tiny quantities of radioactive gold. Not enough for a treasure hunt, but sufficient to gain certain important information about our environment with the help of atomic energy. This sled is used to place the gold-tagged sand at certain predetermined locations. The plastic bags will disintegrate in salt water. Tagged sand is placed along the beach according to a predetermined pattern. These experiments are conducted at Point Magoo, California. Deposits are made also below the waterline. Frogmen place stationary radiation monitors to help measure the radioactively tagged grains of sand that are spreading along the ocean floor. This roller-shaped apparatus, called the ball, is a highly sensitive mobile radiation counter. It is used to survey the gold-tagged sand. The study of one series of placements may continue for a week until decay and pollution make radiation undetectable. The ball is pulled along the beach and through the water. The distance is up to 1,500 feet from the shoreline. The signals picked up by this atomic radiation detector accurately reproduce data as indicated by this map, showing for the first time the movement of the sand under the sea. Rivers, by their very nature, have their own cleaning mechanisms. But ever-increasing amounts of waste dumped into rivers often exceed the flowing water's capability for self-purification. With the use of AEC-produced radioisotopes, the Georgia Institute of Technology is studying the problem. These men are preparing atomic tracers for use in this research work. Bottles containing the atomic tracers, red dye, are emptied into the flowing water. The red dye is used so that the movement of the radioactivity can be easily followed. Samples collected at various points downstream will be taken to the Institute for autopsy. The tests will indicate a decrease of radioactivity of the atomic. These data relate to the amount of oxygen absorbed from the air and will give a much more precise picture of a flowing stream's ability to purify itself. That is, to absorb oxygen, upon which the very life of a river depends. The findings will aid in the proper placement of sewage plants and industrial facilities along rivers and help determine permissible waste output. Industrial wastes are killing fish in the Great Lakes. In order to fight the problem, pollutants are mainly responsible. They collect fish throughout the Great Lakes. The case history of every fish is fed into a computer. Then the vital organs of the fish are removed for analysis. AEC's Argonne National Laboratory, in cooperation with the U.S. Bureau of Fisheries, is trying to isolate the fish killers. Neutron activation analysis is used to identify poisonous elements, such as mercury, copper, zinc, and arsenic, shown here in their specific profiles, their telltale atomic fingerprints. This information helps to provide a picture of the dispersion and types of the pollution in the Great Lakes. Belching batteries of smokestacks used to be the hallmark of industrial success. Today, they are signposts of deep concern to colleges and the medical profession. AEC's Brookhaven National Laboratory, in conjunction with the National Air Pollution Control Office, took off on an airborne program of diagnostic studies to determine the extent and composition of typical plumes and their effects on the surrounding areas. Industrial plumes contain polluting sulfur dioxide. In this compound are naturally varying amounts of two types of sulfur. The ratios of the two types of sulfur can be measured by means of stable atomic isotopes. This information helps determine the intensity and dispersion of corrosive smoke particles and predict pollution patterns over our cities. The planes fly through the plumes at predetermined intervals to gather samples of the spreading pollutants. Samples brought back will provide knowledge of pollutants in industrial smoke. Such information is important to pollution control and will help decrease the damage to man and vegetation in the environment. This geodesic dome, the climatron, houses a tropical forest in the center of the United States at the Missouri Botanical Gardens in St. Louis. Experiments in the fight against pollution are conducted under the guidance of Dr. David Gates, using radioactive tracers to study the way plants convert carbon dioxide into oxygen, and to what extent plants can absorb substances such as sulfur dioxide, one of the most dangerous pollutants from coal-burning furnaces and automobiles. Photosynthesis is a key link in the chain of life. The functioning of the green leaf and other green plants is responsible for the survival of the human race. Changes in the environment due to pollution could jeopardize the process of photosynthesis. So it is essential to investigate the effect of pollution on the plant life of the world. The studies conducted here with the help of the atom yield valuable answers. Other answers will come from experiments in this forest at AEC's Oak Ridge National Laboratory under actual outdoor conditions. The tagging capability of radioactive cesium is used to learn more about the growing process of plants and trees, to help determine the flow of elements through the forest and its grasses, shrubs, and trees. And now, take a look into the possible future of the atom's fight to help our environment. Perhaps underground atomic explosions could provide safe storage space for waste materials. New types of power plants employing nuclear fusion, producing temperatures hotter than the sun, hopefully someday could supply almost limitless pollution-free energy
danger of nuclear attack. In minutes by enemy missiles. In hours by enemy aircraft. Our cities, our farms, our factories. Prime target would be our air bases. With all our aircraft on the ground, our weapons of interception or retaliation not instantly available, we might face another and infinitely more costly Pearl Harbor. Some of our aircraft must always be in the sky or on the alert, carrying nuclear weapons. These weapons are always unarmed. They will be armed only following a decision by the President of the United States. Only these ready aircraft with nuclear weapons can form our first-line deterrent force in peacetime, our sure striking force in case of attack. Understand and accept this necessity for our survival. But we want to know the facts about one question. Do we live in danger of nuclear explosion and radioactive fallout if one of these airplanes should crash? Or one of these nuclear weapons accidentally drop? To give you the facts, the United States Air Force presents this bomber carries a nuclear weapon. It is a well-designed, carefully maintained, skillfully flown airplane. But airplanes, just like it, have crashed and burned. There was no nuclear explosion, no radioactive fallout. These are the facts. The bombardier watches over controls as safe as human ingenuity can make them to prevent accidental bomb release. But nuclear weapons have been dropped inadvertently. There was no nuclear explosion, no radioactive fallout. These are the facts. And specially instrumented aircraft verify these facts in a continuing nuclear safety program that tests our nuclear weapons under controlled conditions that simulate every conceivable hazard. Vital to this nuclear safety program is Air Force Special Weapons Center at Albuquerque, New Mexico. Here, in ultra-modern laboratory buildings, work scientists in and out of uniform. They work with the incredibly complex equations of nuclear physics, which derive from Einstein's famous relationship of mass to energy. These cryptic figures, programmed into lightning-fast computers, are the theoretical base upon which these scientists, together with those of the Atomic Energy Commission, can build nuclear weapon safety. By research, design development, and laboratory test, they ensure weapons not yet built against accidental nuclear explosion. They have been doing this successfully since 1945 in safety conferences with other Defense Department agencies and the Atomic Energy Commission. In 13 years, there have been a few accidents, but not one has resulted in nuclear explosion or radioactive fallout. These are the facts. What keeps our nuclear weapons safe? To understand why there has never been an accidental nuclear explosion, you must first know how these explosions can be produced, the general principles of nuclear explosions. Any explosion is the result of a very rapid release of a great amount of energy. Conventional explosions result from the rearrangement of whole atoms in some explosive material. For example, in TNT, the rearrangement of whole atoms of hydrogen, carbon, nitrogen, and oxygen produces explosive force. On the other hand, nuclear explosions result from the rearrangement within each atom. This may be a joining together or fusion, as in an H-bomb, or the splitting apart or fission, as in an A-bomb. At present, an H-bomb explosion starts with fission. So the splitting of the nucleus of the atom is the basic principle of nuclear weapons. All matter is composed of one or more of the 100-odd elements. Of these, the atoms of the metals uranium and plutonium can be most readily fissioned to cause nuclear explosion. These elements are mildly radioactive. They emit short-range, low-penetration alpha particles while in their unfissioned state. These alpha particles do not have the harmful effects of the longer range and stronger gamma rays, which are given off by certain elements such as radium or by the products of nuclear fission. The atoms of uranium and plutonium are among the heaviest. Heavy because the nucleus of each atom contains large numbers of the fundamental particles called protons and neutrons. When a free neutron hits this nucleus, it splits into two parts, releasing more neutrons which may go on to split other nuclei. The resulting fission products become highly radioactive, emitting the long-range and dangerous gamma rays. The split nucleus weighs less than the full one, and this difference in weight is released in the form of energy, nuclear energy. After fission, harmful gamma radiation. Before fission, innocuous alpha radiation. To build up a nuclear energy release, the fissionable material must be of a certain size, shape, or density. Then one of the neutrons escaping from a split atomic nucleus will, in turn, split another, and a chain reaction is set up. The mass is now releasing nuclear energy, but not quickly enough to cause a nuclear explosion. This condition is called critical. If the mass is now suddenly increased, so that more neutrons are trapped each time an atomic nucleus is split, a multiplying chain reaction is maintained. Now the mass is supercritical, causing a nuclear explosion. Density of the fissionable material can be as important as mass in building up a nuclear explosion. The same sphere can be compressed so that the atoms are closer together and neutrons split more atomic nuclei, making the smaller mass critical. If compressed still more, a multiplying chain reaction sets in, causing the mass to become supercritical in a nuclear explosion. Nuclear weapons make use of both of these principles. A gun-type device can increase the mass of fissionable material to a supercritical state instantaneously. One subcritical mass is propelled forcibly into another by an ordinary Potter charge. The increased mass becomes supercritical. A multiplying chain reaction builds up until the nuclear explosion. Obviously, if any mechanical device keeps these two subcritical masses apart, the weapon is nuclear safe. Applications of this fact prevent accidental nuclear explosions in gun-type weapons. Another kind of nuclear weapon is the implosion type. It compresses the
fissionable material to greater density to make it supercritical. To do this, the sphere is enclosed by a shell of ordinary explosive designed to direct its explosive force inward. This effect is called implosion. The detonators attached to the explosive are connected to a complex firing device, which can fire every detonator simultaneously. When all the explosive is detonated simultaneously, the nuclear material is compressed into a supercritical mass, which results in a nuclear explosion. Implosion-type weapons are nuclear safe because only the specially designed firing device can produce the simultaneous detonation of all the ordinary explosive, a deliberate effect possible only by the precise firing mechanism. Should a single detonator be fired accidentally, whether by malfunction, crash impact, or fire, the explosive would not provide the all-around compression necessary for implosion. Instead, it might push the nuclear material out of the shell, break it into small pieces, or even burn it. This unfissioned material emits only alpha particles because no nuclear explosion has taken place. These alpha particles do not penetrate the skin. The simplest precautions can prevent their intake into the body, and the simplest cleanup measures can remove them. So you see, each type of nuclear weapon has its own safeguards against accidental nuclear explosion. These are the facts.
And they are based upon practice as well as theory. Specially instrumented aircraft fly the tests that verify what happens inside a weapon, what accident hazards the nuclear components may have to withstand. Nuclear safety is everybody's business. Although Air Force flies the test missions, scientists and technicians from the Atomic Energy Commission and other services man the test range and evaluate the findings of the elaborate instrumentation. Drop tests measure impact characteristics of various weapon types. They are made without nuclear components, so that this precious material is not wasted. They supplement the detonation tests that have been made with the complete nuclear weapons. Impact or shock does not cause nuclear explosion or radioactive fallout. What has exploded is the ordinary explosive, which is an essential part of nuclear weapons. The ordinary explosive in a nuclear weapon can be a hazard, exactly as in a conventional bomb. Depending upon the amount and location of the explosive and the speed and height of the drop, we may experience a variety of ordinary explosions. Large ones, small ones, or none at all from impact of the bomb. Beside the hazard of impact, frequent tests are run on the hazard of fire. To learn what temperatures and pressures would be created inside a weapon by an aircraft fire, various types of bombs are subjected to a flame bath of burning fuel. Because fire would also destroy the precious nuclear material, it is replaced by instruments. Their readings are compared with known characteristics of the fissionable material to assure that temperatures higher than any aircraft fire will not set off a nuclear explosion. The characteristic white flame indicates that the ordinary explosive is burning in the weapon. Sometimes the explosive detonates because of close confinement and intense heat. The effects of such explosions are measured and compared with those in an actual nuclear weapon. Fire and ordinary explosives do not create the conditions necessary for nuclear explosion. These are the facts. And on the vast desert ranges of the Atomic Energy Commission, the facts are verified by safety testing live prototypes of all new weapons before they go into production for our stockpile. The tests are costly in money and manpower, even more costly in the fissionable materials on which our nuclear strength depends. But they do provide insurance against nuclear accidents, which make them a bargain at any price. Some take place deep in the earth. Fantastically complex instruments replace the five senses. They record what happens when some of the explosive that surrounds the nuclear material of a new weapon is deliberately detonated. They record only an ordinary explosive blast. A random detonation has not created the implosion which would compress the nuclear material to a supercritical mass. There was no nuclear explosion, no radioactive fallout. Each new design must be proved nuclear safe, able to withstand accident, fire, or random explosive. Other tests with nuclear weapons are made above ground. These are also designed to test the nuclear safety of new weapon types by intentionally detonating the explosive which surrounds the fissionable material. Sometimes these tests also provide data on the side effects to be expected if the fissionable material is broken up by the explosion. Air samplers and test pads are used to gauge the area, intensity, and duration of these side effects. In this way, they learn not only what does not happen when a charge is deliberately fired, but what does. The explosive does break up the nuclear material and scatter parts of it over a small area. This fissionable material is mildly radioactive. If the explosion or fire should suspend any of this material in dust or smoke, it should not be inhaled or otherwise taken into the body in quantity. That is why the trained monitoring and cleanup crews may wear respirators until air samplers or alpha counters have determined that no injurious concentration exists. The alpha particles emitted do not penetrate skin or clothing, so this material is harmless when on the ground. Only simple cleanup measures are necessary, plus an effort to find and save the valuable material. The findings from all tests set up to measure possible radiological hazard are no external radioactive hazard from material on the ground, slight radioactive hazard from prolonged inhalation of material suspended in a small area near the accident, but none from the short exposures necessary for firefighting, rescue, or cleanup of the small area involved. These are the facts. Facts that have dispelled the fearsome myths about accidents involving nuclear weapons. For anyone near an accident, whether or not the crashed airplane carries a nuclear weapon, here are the safe and simple rules. Stay away from the crash unless you are needed for rescue. Bystanders endanger themselves and hamper others. To be safe, keep at least a quarter of a mile away from any burning airplane. At this distance, you are safe from the flames, which may explode the jet fuel, from detonating explosives, and from flying debris. These are the real dangers in rescue or firefighting, as they have always been. The trained men who bear these responsibilities know how to do their job and get quickly away from all these hazards. After the emergency is over, the area is monitored for radioactive material, and, if necessary, cleaned up by specially trained teams. Other specialists care for burned or undetonated pieces of ordinary explosive. Until this is done, access to any crash area is controlled to prevent accidents and speed up the work. The tests you have seen have proved the safety of our nuclear weapons program over and over again. But the grim reality is the payoff. How safe is a nuclear bomber coming in for a crash landing? Detonation of the ordinary explosive in the weapon caused nuclear explosion or radioactive fallout. The safety that was designed in during research, built in during development, proved in the laboratory and on the range, has withstood the ultimate tragic test. These are the facts. They prove that you, the American people, can stay both safe and strong. Safe because the weapons your Air Force must carry have been tested nuclear safe. The possibility of an accidental nuclear explosion is so small as to be practically non-existent. Strong because an Air Force, nuclear armed and combat ready, stands guard against surprise attack. Under this shelter, you and your family may live in peace, free from the fear of nuclear accidents. Disaster is never pleasant. For a long time, schools have been improving ways of protecting children from the kinds of disasters and accidents we have come to expect. Safety measures are essential. Today, however, we are threatened with a new form and magnitude of disaster. For this is the age of the atom. So long as we are confronted with this unprecedented threat, protection of our children must be a basic goal of every educational program. We can achieve this goal only by undertaking a comprehensive civil defense program in all of our schools. protection from nuclear attack is possible. Local conditions will dictate the courses of action. There is a general concept for every school system to follow in developing a civil defense program. First of all, the general objectives and main features of the plan must be carefully worked out by the superintendent for presentation to the school board.
We presented this program to you a week ago at your meeting, and I need hardly tell you that this proposal to expand our school protection program was worked out with the close cooperation of Mr. Miller, our city civil defense director. The program consists of two main parts: protection to take care of our immediate survival needs, and a curriculum program to include civil defense in our courses of study. Before I describe in detail...
In this meeting, the school superintendent is seeking the board's approval of the general proposal. Before he can proceed with a more detailed plan, the board must endorse the proposal and authorize funds for development and implementation of the plan.
Thank you, Mr. Douglas. The board has already studied the outline of this proposal that you gave us last week. Those in favor of proceeding with a more detailed plan? Opposed? Carried. And now I think we should proceed.
A few days later, the superintendent meets with his staff and all principals to explain the new directive and to make specific assignments for detailed planning. The curriculum coordinator heads the curriculum committee. The safety supervisor is appointed chairman of the protection committee. The school architect engineer is made chairman of the fallout shelter committee. Many others, such as the chief school nurse and the head building custodian, are assigned responsible positions. Everyone on the staff has an important role. The Civil Defense Director is present to explain how the schools fit into the total community survival plan. Principals are charged with full responsibility for developing and executing both the protection and curriculum programs in their own schools, programs which will conform with those established for the entire system. Before calling a meeting of the entire staff, principals in turn discuss the program with some of their key people. The school safety supervisor is appointed as the civil defense coordinator, and teachers serving on the curriculum committee are told to prepare for special meetings to find ways of building civil defense into the courses of study. One of the first steps in developing the protection program is to decide on the best and most economical ways of providing shelter from radioactive fallout. With the aid of the local civil defense director, the school superintendent and his architect engineer make detailed plans for including dual-purpose fallout shelters in all new school construction. Plans are approved, funds obligated, and the real work gets underway. When this shelter is completed, it will also serve as the school cafeteria. Existing school buildings throughout the system are surveyed to determine what areas within them are best adapted for shelter use or for ready conversion to shelter. This area, for instance, was formerly used for coal storage, but now it serves as both fallout shelter and workroom for school theatrical productions. This school needed more classroom space, but to add it above ground would have taken away valuable playground area.
The problem was solved by building dual-purpose sheltered classrooms underground according to specifications furnished by the Office of Civil and Defense Mobilization. Alternate plans for evacuating the schools in target areas are also developed. If there is enough advanced warning of an attack, civil defense plans in many target cities call for sending children home from school. Some target cities, such as this one, if there is adequate warning time, plan a general evacuation to safer areas. With the help of the local civil defense director, the school superintendent makes certain that arrangements for evacuating schools in his system are coordinated with those already established for the community at large. Cooperative arrangements must also be made between school and local government officials at reception areas. Development of an adequate internal warning system for the schools also is carefully worked out to supplement existing civil defense warning facilities. This community has a good outdoor warning system with sirens covering the entire area. Everyone here knows that the alert signal, a steady blast of from 3 to 5 minute duration, means to take action as directed by the local government. And that the take cover signal, a wailing tone or a series of short blasts of 3 minutes duration, signifying attack is imminent, means to take cover at once in the best available shelter. To supplement these outdoor signals, an indoor warning system is needed. Although there are other approved systems for instantaneous relay of warning, bell and lights are used here to alert the schools. Public address systems are installed so that emergency instructions can be given to the students and staff in the shortest possible time. Here's how the whole system works. When a warning is received by the local government through the attack warning system, sirens and bell and lights throughout the community are activated simultaneously. Every school in the system receives this signal. On receipt of the warning, the switchboard operator immediately informs the principal. Using the public address system, he gives appropriate directions to his staff and to the students. It cannot be stressed too strongly that any civil defense warning signal used in schools must be clearly distinguishable from other types of alarms. No survival plan for schools can be effective without the full cooperation of an informed staff. The importance of the role of teachers in conducting shelter drills, for instance, cannot be overemphasized. Youngsters gain confidence in arrangements made for their security. While individual schools may have different requirements, all must hold periodic drills to assure immediate response to warning signals. provisions to sustain students and staff for at least 2 weeks. In this combination shelter cafeteria, the cafeteria manager is in charge of emergency feeding facilities. It must be stocked with blankets for everyone assigned to the shelter. If the school is dependent on a vulnerable community water system, a special well may have to be provided for emergency water supply. Battery-powered radios with Conelrad frequencies 640 and 1240 clearly marked on the dials must be available to receive emergency information. A telephone tied in with the city's Civil Defense Control Center. First aid and medical supplies. Sanitation facilities and means for safe disposal of rubbish and wastes. Radiological monitoring equipment. An emergency electric power generator. And adequate ventilation are among the special items which must be provided. Because children would need some form of recreation, an area within the shelter should be available for physical activities and play. Of course, if time would permit, they would be in their own shelters at home. While the protection program is taking shape, civil defense is introduced into the curriculum at all levels. This third grade class, for example, visits emergency facilities in the community, like the local fire station. Here they learn that the people who protect them every day are a vital part of civil defense. In this 5th grade class, children make posters on home preparedness. Gradually, an awareness develops that civil defense is as natural, as meaningful, and necessary as everyday safety rules. The conditions of survival are learned. Preparedness becomes a personal responsibility. Discussion of the effects of natural disasters leads to a realistic grasp of the consequences of a nuclear war. The objective of curriculum planning is to give each student a background in the needs and methods of civil defense so that he will be prepared for living in the nuclear age. Under the supervision of the school nurse, first aid courses are taught as a regular part of the physical education program. These young homemakers in the 10th grade are getting some first-hand tips from their cafeteria manager on ways of preparing food for large groups of people. They learn that there is a real relationship between good food and good morale. Civil defense concept should evolve naturally from existing subject matter, as in this 12th grade class in American government.
Services. And if we were ever attacked, we would need more than ever the help and patience of our government. Both states and many localities have already adopted this program to help us recover and to preserve disaster. Many officials may be unable.
This is a sound peculiar to our time. A sound that is meaningful to this 12th grade physics class studying the effects of radioactive fallout. These radiological defense instrument kits for use in science classes have been distributed to high schools throughout the nation by the Office of Civil and Defense Mobilization. From experiences like this, young people grow in their understanding of the problems they must face, of the responsibilities they must accept as citizens of the nuclear age. If it is to be a successful program in our schools, civil defense must also be understood and practiced in our homes.
It's vitally important to everyone. We have been talking about some of the precautions schools are taking to protect their children and to help them meet the challenge of our time. But I want to stress that it's just as important that we carry this knowledge, these preparations, into the home. Let's take a look at some of the things that we as parents and as citizens are obligated to know. Warning signals, what they mean. Your community plan for emergency action. Protection from radioactive fallout through shelter. First aid and home emergency preparedness. Use for SoundRad 640 or 1240 on your AM radio for official directions. These are some of the things that we must do. Prepare a family fallout shelter and equip it with 2 weeks' supply of food and water, a first aid kit, and a battery-operated radio. If we are in a target area, prepare an evacuation kit for your automobile. Include a supply of food and water, first aid kit, a battery radio, and blankets. First, let's talk about the family fallout shelter. This is a model of one of the types of family shelters recommended by the Office of Civil and Defense Mobilization. It is best to
The protection of our families at home and in schools is basic to the success of any community or national survival program. For the sake of clarity, let's review some of the steps in preparing a school civil defense program. After outlining a general plan with the help of the local civil defense authority, the superintendent makes his proposal to the school board. With the board's approval, he calls a meeting of his staff and principals to explain the new policy. Starting with the emergency plan, a shelter program is developed under the supervision of the architect-engineer who works with the civil defense director. If evacuation is called for in the community survival plan, school procedures are designed to conform with it. The entire school system is provided with a reliable warning system. Individual schools carry out their directives and refine their programs through regular drills and exercises. Following committee recommendations, the curriculum is modified to incorporate civil defense and survival techniques into the existing courses of study. And home preparedness is stressed as a necessary extension of the school survival program. Approaches to the development of school civil defense programs will necessarily vary according to local conditions. But if these guidelines are followed, while working closely with local civil defense officials, schools will be better prepared to meet any disaster. A nuclear war may never come, especially if we are prepared. But we cannot ignore the threat. The stakes
Over 19,000 disasters strike somewhere in our country every year. That's more than 50 disasters every day. Some are major, like Hurricane Camille. I witnessed this awesome destruction. But Hurricane Camille, and even the greatest natural disaster we could imagine, will be dwarfed by the loss of lives and property in nuclear catastrophe. I'm saying this because I have good reason to be concerned. My name is John Davis, and I am the National Director of Civil Defense in Washington, D.C. Our purpose in civil defense is to protect you and to help you protect yourself in time of emergency. That's the reason we have prepared this special film to tell you what actions you should take to help protect yourself and your family in case of a nuclear attack. The protective actions you take today would not be wasted if a nuclear attack did not occur. Experience tells us that these actions save many lives in natural disasters and other emergencies. The surest way to invite disaster is to do nothing to avoid it. You'll give this film your closest attention.
Most likely, the most important fact in the world today is this. We've been living in the atomic age since 1945. It's a long time now. And none of these catastrophes so freely predicted, so honestly feared, have come to pass. True, there have been dangerous moments like the Berlin and Cuban crises. But so far, sanity has prevailed. And hopefully it always will. And yet there's no point in looking away from reality. We live in a troubled and uncertain world, and it's got to go on being troubled for a long time to come. The nuclear genie is out of the bottle. And until the world finds a way to clap it back in, and then put a lock on the stopper, there'll always remain the outside chance that what our nation and a great many others have been working so hard to avoid could conceivably happen after all. And of course, so long as even the slightest possibility exists, it's something we can plan, guard against, prepare for, just through the common sense precautions. So let's talk a little about these things, about what's being done to protect you, and about what you can do to protect yourself in time of emergency. Of course, our first and strongest line of defense lies in what the strategists call the power of deterrence. In our intercontinental missiles, our nuclear submarine fleet, strategic air command, in the ability of all our military forces to retaliate even after a surprise attack, and do it with such enormous force that the aggressor would be defeated, most likely destroyed. And in that fact, that knowledge alone lies the strongest incentive any enemy could have to avoid launching a nuclear war. But behind the sword, there's also a shield. Very quietly, but steadily over the years, we've been building a nationwide system of civil defense designed to save lives, to protect as many of our people as possible. It consists of many things. The National Warning System, tied in with NORAD, the North American Air Defense System, able to alert the whole nation in a matter of minutes. A monitoring network with more than 65,000 locations to measure and report fallout radiation. And most important, a very large and growing public shelter system to protect us from that radiation. Local governments have been making detailed plans to deal with all kinds of disasters. An emergency broadcast system organized to keep you informed. And thousands of special emergency control centers to direct life-saving and recovery operations. In short, if attack ever threatens, there'd be help available from many sources. You would not be alone. But a lot, inevitably, would depend on you. There's no point in denying or trying to minimize the grim fact that a nuclear attack would take a heavy toll of lives. But in all the Defense Department studies, and there have been many of them, two things come clear. Even under heaviest attacks, our nation could, in fact would survive. And our losses would be much less, your own chances of survival much greater, if each of us would take time to do just three things. First, understand the dangers you face. Second, make some fairly simple preparations to meet them. And third, learn exactly what to do if emergency comes, and then do it. 1, 2, 3. Now, about those dangers. There are some you can't do much about, but others you can. And knowing the distinction between the two could very well mean the difference between staying alive or dying an utterly useless death. When a thermonuclear weapon explodes, 4 things happen. First, a brilliant white flash of light. Then, a searing wave of heat shooting out from the nuclear fireball. The blast wave hurling debris before it. But even under heavy enemy attack, only 4 or 5% of our land, 1/20th of the country, would be affected at all by blast and heat. All the rest, and all the tens of millions of people in it, would escape untouched. Except by radioactive fallout. It could spread on the wind to cover not just 5%, but 80 or 90% of our country. But that's one danger you can do something about, if you know a few facts about fallout. When a nuclear weapon explodes anywhere near the ground, tons of dirt and debris are pulverized into millions of tiny particles, swept up into the fireball, turned dangerously radioactive. They drift downwind in the mushroom cloud, then start slowly falling back to Earth. The heaviest and most dangerous particles first, after 15 to 30 minutes in the area nearest the explosion. The lighter ones later, perhaps hours or days later, and hundreds of miles away, wherever the winds may take them. But wherever they fall, in fields and streams, on rooftops, or in the streets, they spell danger. Each one of these fallout particles, no larger than grains of salt or fine sand, is like a tiny X-ray machine, shooting out deadly, invisible gamma rays that can damage or destroy the cells of your body. Too large a dose in too short a time means sickness or death. But it's a useless way to die. Useless because it's unnecessary if you use the 3 defenses you have against it. One is time. The most dangerous period would be the first 24 hours after fallout arrives. But fortunately, radiation decays very rapidly. It's like an elevator going down fast. For example, if all the fallout were down on the ground 1 hour after the burst, then by 7 hours, the radiation would have dropped to just 10% of that 1 hour level. By the end of 2 days, it would be down to 1%. And in 2 weeks, it would be just 1/10 of 1%. In short, with shelter, you can wait it out. But while you're waiting, you'll need protection. And that comes from 2 things: mass and distance. Mass meaning thick, heavy, dense materials. Concrete. Steel. Even ordinary earth to absorb or deflect those deadly gamma rays, reduce the amount of radiation reaching you. And distance, because the farther you are from the source of the radiation, fallout particles settled on the roof or on the ground outside, the safer you'll be. Put those two together, mass and distance, and you've got a fallout shelter. You'll find it wherever you see this sign, the black and yellow sign that marks our community fallout shelters. And they could mean the difference between life and death in time of emergency. Of course, if you're convinced of the futility of it all, and you want to just stand out there and bear your breast radiation, that happens to be your privilege. But as we all found out in the Cuban crisis, that kind of talk becomes just talk. As the real danger mounted, so did our will for survival. We all discovered a reason for living. Ourselves, our families, our children, and we were all looking for shelter. Well, it's there now, ready for use. A nationwide system of more than 100,000 large public fallout shelters located in office buildings, apartments, schools, factories, stores. And it's a good idea to look around, to know at all times where the nearest ones are, just in case they ever prove needed. Of course, there's still not enough, and they're not everywhere. Usually, there's plenty of fallout shelter downtown where most people work, but less in the suburbs where a lot of us live, and not nearly enough out in the country where there aren't enough buildings with heavy construction. If that's the problem, if you're just too far away from the nearest community shelter to reach it in time, then you'd better do something about it. One answer may lie in your own home. If the house has a basement, earth and concrete may give you some shielding already built in. And to help fill in the gaps, the Office of Civil Defense has been conducting home surveys in many of our states, asking each homeowner to fill out a questionnaire, then telling him by means of computer exactly how much fallout protection is already there. If you've already taken part in one of these surveys, you already know if your house has enough. And if it has to, well, usually all it takes to improve, to build a home shelter in your basement, is some do-it-yourself effort, plus a couple of $100 at most for concrete blocks and other materials. And in extreme emergency, if crisis seems imminent and no shelters available, it's still possible to improvise some last-minute protection against fallout. Not as good as you'd find in a regular shelter, but any protection's better than none, and it could be enough to save your life. Remember, use mass and distance to reduce radiation. Choose the corner of your basement that's most below ground level. Set up a sturdy table or workbench there. Wall it in with the heaviest materials you can find. Bookcases, chests of drawers, appliances, trunks. Then, fill the drawers with earth or sand to give added protection. Cover the top with as much heavy shielding as it will hold. House doors, bricks, flagstones, firewood. Then, once your family's all inside, block up the entrance, leaving an opening at the top just large enough to let air in, of course. If you live in the country and your home lacks the basement, a storm cellar outside can serve just as well. If the existing roof is made of light wood, put in extra posts and braces to support the added weight. Then cover the roof with a foot or more of earth to give you solid protection. After everyone's inside, use bricks, sandbags, or heavy concrete blocks to wall up the entrance, leaving just a few inches open at the top, again for ventilation. Or you can improvise a shelter in your yard. Dig an L-shaped trench, 4 feet deep and 3 feet wide. Make the longer side of the L big enough to accommodate your family. The other leg will serve as an entranceway and help reduce the amount of radiation getting into the shelter area. Shore up the sides of the trench for safety. Then cover it with house doors and heavy timbers. Then pile on a foot of earth for protection. As a last resort, even if there's no basement or storm cellar available, You could get some limited fallout protection by improvising a shelter on the ground floor of your home. Use a hallway, an inner room, or large clothesline, away from outside walls and windows. With doors, chests, trunks, and boxes filled with earth or sand, you can create an enclosure large enough to live in for the short time of that first peak period of danger. If the inner space you've chosen is too small to allow room inside for all these shielding materials, place them against the other side of the wall, in the surrounding room. All these are last-minute measures, of course, for use only in extreme emergency if you just can't reach a regular fallout shelter. But it's better not to wait that long to make the preparations, particularly when it comes to supplies. Most community shelters, though not all of them yet, have been stocked with the basic requirements: emergency food rations, water containers, sanitation equipment, medical kits, radiation detection equipment. But even so, in a time of crisis, shelter living would be Spartan, none of the comforts of home. And there are things you'd better plan to take along to help ease that shelter stay. A battery-powered radio, flashlight and extra batteries, a blanket for each member of the family, any dietetic foods or special medicines your family may need for reasons of health, like insulin, heart tablets, antihistamines. If you have a baby, don't forget bottles, disposable diapers, cans of formula, and special baby food. And of course, if your neighborhood shelter is not stocked with the basic supplies, you'll need to take as much water and ready-to-eat food as you can carry. That's true of a family home shelter, too, for here you'd be on your own. So keep a 2-week reserve of supplies around the house for use in emergencies. For shelter use, canned goods are best. Soup, canned meats, all the pre-cooked food. And packaged goods like crackers and wafers that don't need refrigeration. And water. That's even more important, for you can't live without it. As a minimum, 3 or 4 gallons for each member of your family, and store it in tightly capped bottles or plastic containers. If the supply runs low, don't overlook all the alternate sources right inside your house. The canned fruit and vegetable juices on the kitchen shelf. Soft drinks, milk, and ice cubes from the refrigerator. The 20 to 60 gallons in your hot water tank. And of course, all the water trapped in the pipes of your house plumbing system. In case of attack, simply turn off the main water valve in your basement to avoid having it all drain away if there's a break in the outside main. Then, turn on the faucet located at the highest point in your house, probably the upstairs bathroom, to let air into the system. Then, draw the water as you need it from the faucet located at the lowest point. It'll be pure, drinkable, and free from fallout. If some fallout particles are on food that you brought in from the outside, don't worry. They can't make it radioactive. Simply remove the particles, and you remove the danger. Just wash or peel the fruits and vegetables. Wipe off the packages or cans. For safety, it's better to make sure that babies or small children aren't allowed food or liquids that might be contaminated. However, in extreme emergencies, thirsty people should not be denied water, even if it contains fallout. There's little danger that any adult could swallow enough to hurt him. It'd be like trying to swallow sand. Of course, we've only skimmed the surface here of things you need to know and do. But you'll find everything covered in fullest detail in this Citizen's Handbook prepared by the Office of Civil Defense. It's titled, In Time of Emergency. It deals with natural disasters as well as the dangers of enemy nuclear attack. And you can get a copy from the Civil Defense Office of your own local government. Read it. Study it. And above all, Keep this quick checklist of emergency actions in mind. First, know your local emergency action plan. Hundreds of cities and counties have prepared and printed specific community shelter plans, complete with maps and detailed instructions, telling every resident where to go for the best available protection against fallout. Make sure your family knows the plan, where the nearest shelters are, and how to get there in time. Second, keep a stock of emergency supplies on hand. Foods that require no cooking, enough drinking water and other liquids, special medicines, radio, flashlights, blankets. And if you're planning to use a home shelter, don't overlook the problem of sanitation. Lay in a metal container with a tight-fitting lid, some plastic liners, and household disinfectant. You'll need them for disposal of waste and prevention of disease, to keep your family healthy through a shelter stay. If attack seems imminent, take precautions against fire. Close doors, windows, Venetian blinds. If you don't have Venetian blinds, cover the windows with household cleaning powder, aluminum foil, whitewash. For even in the fringe areas, miles away from any nuclear explosion, the heat wave could ignite trash and dry wood, set fire to your home. Have some basic firefighting tools on hand, especially a good fire extinguisher, and keep your garden hose connected. Unless your local authorities advise otherwise, fill the bathtub and other containers with water. For under enemy attack, the fire department may not be available. You'll have to help yourself. Above all, make sure you know what your local attack warning signal is. There are a few exceptions because of special local conditions, but in most communities, the standard attack warning is this. A wavering, undulating sound on the outdoor sirens lasting 3 to 5 minutes, or a series of short blasts on whistles and horns. And when you hear that sound, believe it, an actual enemy attack has been detected. Don't reach for the phone to find out what's happening. The lines need to be kept clear for official emergency use, and you need to find shelter promptly. If you're caught in the open, if there's a sudden flash and you feel warmth at the same time, don't look at the flash. Move. Take cover instantly, behind a tree, or a wall, in a ditch, or a culvert. Curl up on the ground and cover your head with hands and arms. Stay there till heat and blast waves have passed. Then get to shelter before the fallout starts falling. Then turn on the radio. The emergency broadcast station serving your area will be bringing you news, presidential messages, civil defense instructions. You would not be alone. In many shelters, you'd find friends and neighbors who've been specially trained in shelter management, radiological monitoring, medical self-help. All across the country, the Civil Defense Monitoring Network would be measuring and reporting fallout conditions. And from the state and community emergency control centers, your own local authorities would be directing life-saving and recovery operations, keeping in close touch with each shelter. Just follow their official instructions and stay in the shelter until they tell you it's safe to come out. All these things are easy to remember and fairly simple things to do. None of them cost much in time or effort or money. If nothing ever happens, if the world maintains its sanity and enemy attack never comes, that time and effort will still have been well spent. For the better, both we and the nation are prepared. The less chance, really, that anything will happen. And if they ever prove needed, they could save your life in time of emergency.
sudden or extraordinary misfortune. If people require medical care in the course of normal, everyday living, they should always be treated by a doctor. However, when disaster strikes, you may not be able to obtain trained medical aid in time. There are many forms of disaster. They can happen to you and your family at any moment. This film is one of a series on medical self-help. Its purpose is to teach you what to do in an emergency situation when there is no doctor.
This powerful X-ray machine, a tool of medical science, is being used for healing purposes. The radiant energy it emits is able to kill all living tissue within its beam, both sick and healthy cells of the human body. Its invisible rays so highly penetrative that protective shielding with lead glass windows must be used. X-rays are much like the gamma rays of radioactive fallout. We began our picture with X-rays because you are all to some degree familiar with their effects. But radioactive fallout is another matter. If you're like most people, it creates many questions in your mind, and you have doubtless read or heard some falsehoods and misconceptions. This film will tell you what you need to know about fallout, so that if our country is ever subjected to a nuclear attack, you can help yourself and your family to survive its dangers. For fallout is probably the most dangerous product of nuclear disaster in terms of the number of people who could be affected. It is also the one from which we are best able to protect ourselves. Let's examine what happens when a nuclear weapon is exploded near the Earth. First, there is blast, or the pressure wave created by the explosion, along with heat, the most intense ever created on Earth. Both will extend great distances from the point of the explosion, from 1 to 20 or 25 miles, depending on the size of the weapon. However, the further away you are from the site of the explosion, the less are the chances you will suffer the fatal effects of blast and heat. There is yet a third immediate result of a nuclear detonation: initial radiation. The final effect is residual radiation, the main concern of this film, or radiation that follows the explosion and one that may remain at high altitude for some time before falling back to Earth. What exactly is residual radiation? Our sun, like other stellar bodies of the universe, is a giant nuclear furnace, burning at temperatures of millions of degrees, while emitting various types of radiation. Among these are gamma rays, shorter in wavelength than their closest neighbor, X-rays. The Earth's atmosphere prevents these radiations, dangerous to the health of man and animal, from reaching our planet. However, when a nuclear weapon is exploded, man is creating on Earth, in the splitting of atomic nuclei, his own nuclear furnace to produce the gamma and beta radiations of outer space. Let's see now just how this radiation is created. At the time of the burst, vast amounts of dirt, stone, and other debris, vaporized by the heat of the explosion, are sucked up into the rising cloud. As the mushroom cloud forms, these particles are made radioactive, for as they cool and condense, they are contaminated by residue from the bomb. These particles, when they fall back to Earth, are what we call radioactive fallout. Can you or anyone else predict with accuracy the pattern by which fallout particles will return to Earth? The answer is no, for fallout will depend on the number, size, and location of nuclear weapons exploded and the direction of upper air currents. Let's, for example, explore the fallout produced by one of these nuclear weapons. It sends its column of radioactive material up to 80,000 feet, or about 16 miles or more above the Earth. Here, the radioactive particles, beginning to drift downward, are at the mercy of upper air currents that vary from day to day. Descending at various altitudes through many different layers of air that may be moving at varying speeds and directions. Thus, winds on the surface of the Earth give little help in determining the direction or the occurrence of fallout. Meteorologists, with their special instruments, however, can appraise altitudes as well as the total distance fallout will be carried. In a nuclear attack, keep tuned to your local radio station. It will keep you posted where fallout is taking place and its approximate amount. Though you may be able to see this dust once it reaches the Earth, you cannot see or detect the radiation it emits without the aid of radiological instruments. Nor can you taste, smell, or feel this radiation. Why is fallout so dangerous to human and animal life? Because each particle gives off radiation as if it were a tiny X-ray machine. This radiation consists mainly of gamma rays, which are extremely penetrating. Like X-rays, gamma rays are able to injure, even destroy the cells of our body if we are exposed to a sufficient dosage long enough, or if we eat or drink material contaminated by fallout particles. Exposure to gamma rays can make you sick, can even cause death. However, no matter how long one may be exposed to fallout, he does not become radioactive, nor can anyone catch radiation sickness from him like a contagious disease. In fact, this radiation cannot make anyone or anything radioactive. Now let us suppose that fallout has descended on this can. We'll let salt represent fallout dust. The particles don't go through the tin. The radiation does. But radiation is harmless to all except living material. It has no effect on the food inside. Now, if you wipe away the fallout particles, or better still, wash them away, the food inside cannot be contaminated and is perfectly safe to eat. The same is true of all foods and liquids that have been protected by packagings or containers, even the thinnest layer of cellophane. If you don't swallow the dust, there is no ill effect. If water for washing is in short supply, canned goods that may have been exposed to fallout can be handled safely with a piece of paper towel. Use one sheet of paper to lift the can and turn it upside down. There is no dust on the bottom. Now dispose of the paper. Wipe the sides of the can with a new piece of towel. And don't forget to put the contaminated paper in a covered receptacle. Now open the clean top. There will be no harmful particles in the food itself. A sealed loaf of bread that has been exposed to fallout can be salvaged in a similar manner. Turn the loaf upside down to expose the bottom, which will be clear of dust. Then dispose of the towel. Now insert a sharp knife through the wax paper at the center of the loaf and cut upward, making a slot 4 or 5 inches lengthwise. Insert your fingers through the slot and rip the paper slowly open. The bread can be safely removed to a clean place. Finally, dispose of the wax paper. Contaminated vegetables, such as potatoes, can be pared like this. Use a clean piece of newspaper and, working first in one corner, cut off one edge. Move to a clean surface of the paper and peel in this manner. Move to another area of the paper and remove the other edge. Dispose of all peelings and soiled paper carefully. After handling any contaminated food containers or vegetables, wash your hands. Fallout dust is dangerous, but it can be dealt with by following safe procedures. There's another widespread legend, the fear that fallout spells death to all life on Earth. The plain fact is that even if a great number of nuclear weapons were exploded, the resulting fallout would cover only a small area of the world's total land mass. The real concern then is this: if we are in that area, how do we protect ourselves? Like X-rays, radiation from fallout can go through almost every kind of building material. Over 99% would pass through glass, 66% through wood sheathing, 50% through a brick veneer wall. But only 1% of gamma radiation would penetrate 18 inches of concrete. And though it's not a building material, it's important to know that only 1% would pass through 25 inches of earth. Quite aside from the shielding effect of building materials, the intensity of radiation decreases with the square of the distance from the source. Thus, 10 feet away from a particle of fallout, the radiation rate is only 1% of that encountered at a distance of 1 foot. Other things being equal, the central parts of a building are safer. The radiation rate, or the intensity from fallout, decreases with the passage of time. In fact, for every 7-fold increase in time, the radiation will be reduced by a factor of 10. That means that at 7 hours after the explosion, the radiation level will be about 10% of its intensity at 1 hour. At 49 hours, it will be about 1%. Within 2 weeks, the radiation rate can be expected to decay to about 0.1%. Therefore, the most vital period to seek protection from fallout is the first few days after nuclear attack. Even more so, the first few hours. But remember, even with the passage of time, a low level of radiation can be dangerous. That is why you may need to remain within a sheltered area for as long as 2 weeks. These then are the 3 basic factors in protection against fallout: time, distance, and shielding. Time, meaning the longer you stay protected from fallout, the safer you will be. Distance, or the further away you get from fallout, the safer you will be. Shielding, meaning the more mass or weight you put between yourself and fallout, the safer you will be. You have often seen this sign on buildings. It means that indoors is a public fallout shelter, one of many and various kinds of buildings in your community that are similarly identified. Architects and engineers have carefully surveyed the shielding qualities of these areas to ensure they offer a minimum protection factor of 40 or more, meaning that in the event of fallout from a nuclear explosion, the mass and weight this shelter will place between you and the source of radiation will make you at least 40 times safer than if you were outdoors. Each of these shelters will hold at least 50 people and has been stocked by the government with austere supplies: food, water, sanitation equipment, medical kits, and radiological instruments. But what about millions who live in suburbs or rural areas, often far beyond quick walking distance of the nearest public shelter? With foresight, you can have a home shelter for the protection of your family, built from specifications and cost estimates for various types of shelters provided by your local civil defense office. The home shelter should be stocked with supplies of food and water sufficient for 2 weeks. Here you are afforded time, distance, and shielding if and when fallout so dangerous to human health should ever occur in your community. Just how much radiation can you receive without becoming sick? We measure exposure to gamma radiation from fallout in units called Roentgen. They're the same units used to measure X-rays, named for Wilhelm Conrad Roentgen, the discoverer of X-rays. People and animals may develop radiation sickness if they have been exposed to large amounts of radiation over a short period of time. Few people become sick who have been exposed to a total radiation dose of 100 Roentgens or less. However, exposure to more than 300 Roentgens over a period of a few days will cause sickness, may cause death. And if you receive an exposure of 600 Roentgens in that same period of time, death is almost certain. How can you tell just how much radiation you've been exposed to? These are the instruments commonly used to detect and measure radiation. They are part of the equipment supplied to the radiological monitoring team of every public shelter. With them, you can determine not only the total amounts of radiation received, but also the dose rate per unit of time, or the dose rate in Roentgens per hour. This is the dosimeter, conveniently shaped to be worn on one's person at all times. It is able to measure the total accumulated radiation exposure in Roentgen. The charger adjusts the dosimeter to a zero reading prior to its use, with each separate exposure to radiation building cumulatively on the dosimeter gauge so that a reading of the total dose is available at any given time. Next, the Geiger counter. This instrument measures radiation in fractions of Roentgens per hour within or outside the shelter. Finally, the survey meter, able to measure higher intensities of radiation that may exist outside the shelter. For home shelters, detection and measuring instruments are available from commercial sources. However, most householders will rely chiefly on their portable radios to receive readings as they are taken by civil defense monitoring teams. If there is a nuclear attack, and you survive the initial effects of an explosion, you will have at least a half hour to get to a public or home fallout shelter. Therefore, to be safe from radiation sickness, get into the best available shelter as soon as possible. Once there, stay put, because each time you're exposed to fallout radiation over a period of a few days, the dosage continues to build until it reaches dangerous quantities. If you're among those compelled to travel through a fallout area on essential errands, there are certain rules to follow. Protect your body with boots or rubbers, gloves, headgear, and outer clothing that can be removed before you re-enter the shelter. On returning, brush off the rest of your clothing thoroughly, as well as any parts of your body that may have been exposed to fallout. If sufficient water is available, wash your face and hands carefully. Remember, these are the dosages of radiation as they affect human health. 100 Roentgens, little or no effect. 300 Roentgens, sickness or death. 600 Roentgens, death. Recovery from radiation sickness is nothing new. Patients who are treated by X-rays routinely experience this sickness and get over it. Of course, the dosages they receive are carefully measured. Just as in combating the virus of the common cold, your general state of health will often govern how quickly you can throw off the effects of mild or moderate radiation sickness. In an emergency situation where there is no doctor, always treat radiation sickness by treating its symptoms. In fact, these symptoms are often similar to those produced by extreme anxiety or emotional stress. So it's best not to try to determine their cause. I repeat, do not try to diagnose. Merely treat the symptoms, just as you would if they were the result of any other type of illness. These are the symptoms of mild as well as moderate radiation sickness, one or more of which may appear shortly after exposure to fallout. Fatigue, loss of appetite, nausea, vomiting, prostration. The treatment is rest. For nausea, you may give the patient any of the commercial preparations that settle an upset stomach, or 1/2 teaspoon of baking soda in a cup of water. Tea and other hot liquids may be helpful. When a high fever is present, apply cold wet packs. Aspirin also tends to reduce the fever. In severe radiation sickness, along with the early symptoms, other symptoms may appear a week or more after exposure. Recovery is possible, but it'll take longer. The symptoms are diarrhea, inflammation of mouth and throat, loss of hair. For treatment, control the diarrhea and give aspirin and warm water gargles. People are naturally alarmed at the thought of bodily changes that may follow severe radiation sickness, such as loss of hair or sterility. These conditions are usually temporary and will disappear with recovery. So I hope we've dispelled another commonly held myth. You can get over radiation sickness just as you get over many others. Nevertheless, don't minimize the danger of fallout. Remember, its effects are cumulative. The only real protection against it is to take shelter. Now, let's review some of the outstanding facts we have learned in this brief exploration of a vitally important subject. Fallout is composed of trillions of particles of dust that are made radioactive by residue from the nuclear weapon during the aftermath of the explosion. In a nuclear attack, depend on your local radio station to tell you where fallout is taking place. You may be able to see some of the fallout dust when it reaches the earth, but you cannot taste, smell, or feel the radiation itself. The gamma rays given off by fallout are able to injure or destroy the living cells of our body if we are exposed long enough. Food or water in containers that prevent contamination by fallout dust is perfectly safe. Radiation is harmful only to living tissues. Packaged foods that have been exposed to fallout should be opened carefully. By following proper procedures, you can eat such foods without danger to health. Radiation can pass through most building materials, but its intensity is diminished in proportion to the weight and mass of the material or the shielding. The intensity also decreases with distance from the fallout. The radiation rate will decrease or decay rapidly with time. It is most dangerous in the first few days after explosion. Thus, the three basic factors that protect you from fallout radiation are time, distance, and shielding. You should know the location of the nearest public shelter in your community. Inside it, you will be at least 40 times safer from fallout than you would be outdoors. And it has been stocked with supplies to sustain its occupants for up to 2 weeks. If you're not within walking distance of a public shelter, you can provide a satisfactory home shelter for your family. Radiation is invisible, but we have accurate instruments with which to measure it in Roentgen units. The dosimeter can be worn on the person and measures the accumulated radiation exposure, the total dose at any given time. The Geiger counter measures radiation in fractions of Roentgens per hour, inside or outside the shelter. The survey meter is used to measure the higher intensities of radiation that may be present outside the shelter. Assuming that you have the protection of a good shelter within a half hour after nuclear attack, you will probably have little or no radiation sickness. If there are victims who appear to have radiation sickness, do not diagnose. Treat the symptoms. Perhaps the most important thing you have learned is to see the danger in its true perspective. Make no mistake, nuclear attack would be a terrible catastrophe. Millions of our people would be killed by the initial blast and heat. Millions more would be threatened by death from radioactive fallout. But that is a threat that can be combated. Can, with knowledge, preparation, and courage, be faced and conquered.
be a time of growing international tension. All the signs that warn us. Perhaps we need time for some preparation. Wherever we live, we're all inclined to think of our own hometown as target number one. But this is a very big country, with many cities, industries, military bases. if they were perfectly distributed. Unfortunately, they're not. If you have a public shelter far away, stay home and find shelter there. If you have a home fallout shelter in your building, fine. If not, we'll tell you later how to improvise fallout protection. For people who live in the high-risk area, a third defense is possible if there is time. Temporary relocation. In a nuclear attack, the greatest danger would be blast and fire in the target area, which means the people most threatened would be those living or working near our missile sites, near strategic military bases, and near some of our larger centers of industry. The simplest way to save them is to move them out to small towns and rural areas where the only likely danger is fallout. So the federal government, in cooperation with state and local governments, is now working on detailed plans for temporary relocation of these high-risk areas, with frankly, it is a difficult and complex problem, requiring much planning. But it is possible. After all, we relocate millions of workers across the existing building blackout. We have moved hundreds of thousands to safety in time of hurricane or flood. And in a case like this, it could save as many as 100 million lives. It would be an orderly, controlled evacuation. Your own local authorities will give detailed instructions through radio, television, and the press, telling you what necessities to take along, what arrangements have been made for transportation, by bus, train, or private car, where you will find safety in a small town or rural post area, and what routes to follow to get there. When you arrive, reception centers will be there to welcome you and assign you temporary housing. And special arrangements will be made to upgrade the local level of fallout protection in case the crisis should be followed by attack. In fact, we need fallout protection in place everywhere, so there's no telling where it may be needed. But even if you're unable to reach the shelter, you can still improvise some protection. Set up a strong floor workbench in the corner or control ground level. Cover it top with as much heavy material as it will safely hold. Doors, crates, flagstones, books. Wall it in with heavy bookcases, chests of drawers,
root cellars. Cover the cellar with a foot or two of earth. Then shield the entrance with brick or block to protect you from radiation. Of course, the best home protection of all would be a basement fallout shelter, built before any crisis occurs. Your local civil defense director can supply the plans. With a little time, some money for materials, and do-it-yourself labor, you can supply the rest. Wherever you are, you'll need emergency supplies. If fallout in your area is light, you may be in shelter only a few days. But to be on the safe side, store enough pre-cooked, canned, or packaged food, plus special food for the baby, diet food for the sick and elderly, and enough water to last you if necessary for a week or more. Water is the most important. You'll need at least a quart, better yet a gallon, for each person for each day. Store it in tightly sealed glass or plastic bottles. You can also use the bottled or canned beverages, fruit and vegetable juices, and milk from your refrigerator. Then there's your hot water tank. Water in the flush tank, not the bowls of the toilets. And water trapped in a house piping system. Close off the main valve to keep that precious water from draining away into the outside main. Turn on the faucet located at the highest point in the building to let some air into the system. Then, drain water as needed from the lowest point. Don't forget sanitation supplies. A metal container with a tight lid for an emergency toilet and toilet tissue. A garbage can for wastes. Plastic liners and disinfectants. Medicines and first aid supplies. Blankets and bedding. Extra clothing and underwear. Soap, towels, personal hygiene items. Flashlight and candles. Fire extinguisher and buckets of sand. And a battery-powered radio with extra batteries, so you can see the news and official instructions. If you're going to a public fallout shelter, bring as much water and ready-to-eat food as possible. Extra clothing, blankets, a flashlight, special medicine, and personal hygiene items. If you're being moved to safety from a high-risk area, pack all the other basic necessities your family takes from going on a trip. Plus blankets, bedding, special medicine. For your own protection, remember these basic facts. First, the attack warning signal. A 3 to 5 minute wavering sound on the sirens. Or short blasts on whistles or horns. Next, the effects of a nuclear explosion. A blinding flash. The heat wave. Then the following blast wave. And finally, radioactive fallout. Remember your 3 defenses against fallout. Mask. Thick, heavy, dense materials to shield you from the radiation from fallout. Distance. The farther you are from the fallout, it's settled on the roof and the ground, the safer you'll be. And time. Radioactivity does weaken rapidly. With shelter, you can wait it out.
battery-powered radio with you. Then tune to your local emergency broadcast station. They'll tell you when it's safe to come out. Don't forget spare batteries for your radio. Remember, too, that you have 3 choices. 1. Go to a public fallout shelter. Know where the nearest one is. Your office, your home, your children's school. Prepare to take along food, water, the other necessities we mentioned. If you decide to take shelter at home, know how to improvise and improve your protection there. And do lay in enough supplies. Relocation. If you live in a high-risk area, your local authorities may ask you to move to safety in a small town or rural area. Be sure you know their emergency plan, so you'll know exactly where to go and what to do. Whatever the choice, take time now to make your own family protection plan. Know what you'll need. Make your plan practical. Make sure each member of the family knows exactly what to do if crisis ever comes. Don't wait till you need it. That's too late. Do it now.
The Earth from space can seem a fair and pleasant place. And perhaps through strength and unceasing efforts to settle international disputes by peaceful means, we'll manage to keep it that way. The greatest danger is hopelessness. The fear that nuclear attack would mean the end of our world. So why not just give up, lie down, and die? That idea could bring senseless and useless death to many. For protection is possible. And your own chances of survival will be much greater if you remember these facts about protection in the nuclear age.
simple tools in the hands of skilled craftsmen have helped to build the world we know today. A world of towering steel, of giant airplanes, fast-moving transportation, a world of mechanical wonders, products of fine craftsmanship whose origin lies in the proper use of simple hand tools. But to more fully appreciate these tools and their part in our world today, let's turn back to pages of history. 60 or 70,000 years ago, long before the beginning of civilization, our primitive ancestors lived in caves, and we today might also be living in caves, except for a certain event that took place within the gloomy depths of this long-forgotten cavern. Here, a certain Stone Age craftsman by the name of Primitive Pete stumbled upon a very good idea. He suddenly realized that by fastening a stick to a rock, like this, he could extend the length of his arm, like this, and thereby greatly increase the force of his blow, like this. Thus was born the world's first practical hand tool. Oh, did we say practical? Well, anyway, it was a good idea. In fact, it eventually led to the development of all the numerous sledges and hammers we have today. But more than that, out of Pete's Stone Age hammer came other tools, tools for every purpose. This ball-peen hammer, for example, is just a practical version of Primitive Pete's first crude invention. But like all tools, there's a right and wrong way to use it. There are still Primitive Petes among us today who would abuse this fine tool. And this would be the horrible result. Obviously, this hammer was never intended for crushing rocks. The ball-peen hammer was designed for many purposes. The peen end can be used for riveting. It's also used for shaping soft metal. When using the face, you can avoid damage when hitting a hard object simply by striking with a full face. Never strike the object with the edge. Of course, there are many other types of hammers, all based on the original Stone Age model. There's the brass or copper, the rawhide base, plastic tip, and the claw hammer, which is the most commonly used. Or we should say most commonly misused. To use the claw hammer correctly, rest the head squarely on the nail. Give the nail a slight starting tap. Then drive it in with steady blow. A long nail can be pulled part way with the natural leverage of the claw. Then a block of wood placed under the head will increase the leverage, making a stubborn nail easier to pull, with less strain on the handle. A hammer with a loose head can be plenty dangerous. Here's how Primitive Pete would tighten the head on his hammer, but that only damages the handle at both ends. Have you a little beauty like this in your home? A steel wedge is the right answer. Driven into the wood, the wedge spreads the handle to the tapered sides of the eye and holds it tight in both directions. Gripping the handle too close to the head reduces the force of the blow, and sometimes makes it difficult to drive a nail in straight. Always grip the handle close to the end to increase the length of the lever arm and make each blow more accurate and effective. Never use a handle for a crowbar.
That's going all the way back to primitive Pete. Another familiar tool that takes an awful lot of abuse is the ordinary screwdriver. Our modern-day primitive Pete often uses a screwdriver to pry open a stubborn window. Well, maybe he'll succeed in ruining the tool. This never would have happened if Pete had known more about the screwdriver. It's made up of three principal parts: handle, shank, and blade. Some screwdrivers have a full-length shank extending through the handle. But many household screwdrivers have a shorter shank pinned to the handle in this fashion. This type will not stand a primitive Pete treatment. The best rule is never hammer on any screwdriver. Many of us try to use one screwdriver for every size of screw head. Always choose a screwdriver with a blade equal in width to the length of the slot. Another thing, never attempt to turn a tight screw if there is too much play between the blade and the slot. A bad fit can cause serious trouble. It can ruin the screw slot or the blade. This looks like the work of primitive Pete. Well, so it is. Fortunately, if the blade is not too badly chipped, it can be reground in a serviceable shape. First, grind the tip straight and square with the shank. Then grind each face a little at a time, but never allow the blade to become hot. Excessive heat will draw the temper and the blade will become soft. Here are the front and side views of a properly ground screwdriver. Here's a little trick. If the faces of the blade are tapered in slightly, a short distance back of the tip, the screwdriver will stay down in the screw slot, even when a severe twisting force is exerted. Here is a special type screwdriver designed for heavy duty. The extra-large square shank will stand a wrench if added leverage is needed. Don't be a primitive Pete and resort to the use of pliers. They're apt to chew up the shank. Pliers are made for other purposes. Here are some familiar types: combination, diagonal cutting, long round nose, and side cutting. These side cutting pliers are used chiefly for electrical work. To make an electrical connection, first cut the insulated wire to the required length. Then use the parts back of the joint to flatten the insulation, like this. Then grip the insulation with the cutting edges without biting into the solid wire and strip off the insulation. Now right here is where long round nose pliers come in handy. To make a neat loop to fit a terminal, first use the tip of your pliers to make a right angle bend. Then grip the wire farther up and turn the end into a loop. These diagonal pliers have their cutting jaws at an angle. They're very useful for removing and installing cotter pins. A drop of oil every now and then is good insurance against rust. Like all tools, pliers should be kept in good working order. These
These combination pliers, equipped with a slip joint, are very commonly used. They usually have a small shear between the teeth and the joint for cutting wire or nails. Think of these pliers as a set of extra, stronger fingers, valuable for all sorts of jobs. They should not be used to tighten or loosen nuts. The jaws might slip, chewing off the corners of the nut. A better tool for this job would be an open-end wrench. They usually come in sets, with openings ranging in size from 5/16 of an inch to 1 inch. Wrench measurements refer to the distance between the jaws. Use a wrench that always fits the nut exactly. Pushing on a wrench when the nut is tight is bad practice. Better not, Pete. We're warning you. Well, some people have to learn the hard way. On open-end wrenches, the head is set at an angle to the handle, usually 15 degrees. This permits efficient use in close quarters. For example, this nut has very little swing space around it. To start the nut, the wrench will fit one set of flats in this position. And we can give the nut a partial turn before the handle jams against the block. But if we try to repeat the action, we find the nut is in a new position and the wrench won't fit. So we flop the wrench over and get a new fit on the nut. Again, we pull the handle as far as it'll go. We keep repeating the procedure until the job is finished. An ingenious development of the open-end wrench is this type. Its adjustable jaw makes it handy for many sizes of nuts and bolt heads. But the jaw should always be set for a snug fit on the side of the nut before exerting any great force. To use the wrench correctly, the pulling force should be applied to the stationary jaw, like this. Great force applied to this weaker adjustable jaw might ruin the tool. This type of wrench is not intended for hard service, so don't overstrain it. And remember to keep the moving parts well oiled. There are many uses for a medium-sized monkey wrench. This tool also is often abused. The jaws should always be adjusted to a tight fit. And remember to exert the pull on the right side, opposite the opening. If the wrench is used the wrong way, it might slip off the nut and do a lot of damage. See what we mean? Trying to force a stubborn nut by hammering on the handle of the wrench is a sure sign that you're a primitive Pete. If you really want to ruin a good tool, try this on your monkey wrench. You can ruin yourself, too. What Pete needed was a bigger wrench. And we should remember that there is a proper tool for every job if we'll only take the trouble to use it. Pipe wrenches are used for turning pipes, pipe fittings, and other round objects. The teeth of the pipe wrench will not grip the fitting unless the tool is worked in the correct position. For best results, the bite should be taken at the center of the jaws. Remember, the teeth will always leave their mark on the work. However, if you must use a pipe wrench on plated fixtures, you can first wrap the pipe with a leather strap. This will perfect the finish. A popular wrench with mechanics is the box wrench, designed for use in close quarters. The 12 notches in the head of this tool make it possible to get a good fit over the nut in almost any position. Notice the nut is gripped at all 6 corners. To ensure a working clearance, the head of this wrench is offset from the handle at a 15-degree angle. Some mechanics call this tool a knuckle saver. Here's a combination of a box and open-end wrench, sometimes called a half and half. The box end is ideal for breaking loose a tight nut. Then, if there's no clearance for a full spin, the open end may be used to turn the nut off more quickly than the box end. Every workshop should have a set of socket wrenches with at least one handle to fit the different sockets. However, a good mechanic needs a larger set, like this one, with a dozen sockets and several handles for different types of jobs. These special handles provide leverage in almost any position. For example, this hinged offset handle can be worked at various angles. This T-handle with a universal joint allows use in very confined areas where it would be difficult to work with ordinary handles. A further improvement is a ratchet handle. With this tool, the ratchet lever can be set so that the wrench pulls in either one direction or the other and ratchets in the opposite direction. When Primitive Pete attached a simple handle to a piece of rock, he became the inventor of the first hand tool known to man. And from this beginning, through centuries of trial and error, came the vast array of fine tools we have today. Most of us take our modern tools for granted, not realizing what a vital part they play in our daily lives.
Ranging from light to intense over much of the nation. Weapons exploded close to the earth caused greatest fallout ever. Thousands of tons of earth particles are drawn upward into descending rushing clouds, where radioactive particles, nuclear explosions, and temperatures. These particles are carried by the high altitude winds for many miles. Eventually, they settle to Earth, and this is called radioactive fallout. We are all subjected to radiation from outer space and from radioactive material at the Earth's crust. We're exposed to it, and the doctor x-rays us, and on many other occasions. Radiation in small or controlled amounts like that are not dangerous. But in large amounts, the amounts produced by nuclear explosions, radiation can make you seriously ill or even kill you. Radiation produced by nuclear weapons presents a revolutionary threat to our country. In an enemy attack, it could become a direct threat to us all. Fortunately, there are means of protecting ourselves, means so effective that civil defense officials believe everyone can survive home if they take a few simple precautions to protect themselves. The biggest danger from fallout is the fact that the particles do not have to touch you to endanger you. Their deadly rays can penetrate any kind of material, but the material through which they pass absorbs part of the radiation and protects you. Your safety depends upon putting a sufficient mass between yourself and the fallout. Concrete, brick, earth, or sand are the best. In a pinch, any heavy material will do. Civil defense officials recommend that everyone prepare a shelter. In most areas of the country, you would receive ample protection in a basement shelter constructed of 8-inch concrete walls. This provides the same shielding as 12 inches of earth, 16 inches of wood, or 30 inches of wood. To be certain of adequate protection, however, the shielding should be that equivalent of 3 feet of earth. Civil defense officials recommend that for the best fallout protection, your family have these two things: an approved fallout shelter and enough supplies to enable you to stay in it for a maximum of 2 weeks. Within that 2-week period, it is estimated that community resources will have been restored to give you some help. A short time later, assistance should be available from the state and federal government. Get started right away at protecting your family from fallout. Plans for approved shelters are available from your civil defense officials. Some of the shelters you can build yourself. The more elaborate models can be undertaken by a contractor. Let us look at 5 shelters developed by the Office of Civil and Defense Mobilization, any one of which will provide good fallout protection for your family. First, the basement concrete block shelter is specifically designed as a do-it-yourself project. The cost will vary according to your area, but should range between $150 and $200 for materials. It would provide all the protection needed in most areas. You must be sure the shelter has proper doorways, air vents, and ceiling beams capable of holding 2 layers of concrete blocks. Plans for this shelter can be incorporated easily into new home construction. In all of these shelters, instead, you must be sure to use solid concrete blocks rather than the hollow variety. A hollow kind will not give adequate shielding unless they are filled with cement, sand, or earth. The second recommended shelter is the above-ground double-wall shelter. It is an outdoor, above-ground construction, also may be built with concrete blocks. It is ideal for regions where water or rock is practical to build underground. Most people would want to hire a contractor to build it. Materials would cost about $700 plus contractor. Virtually absolute protection from fallout is furnished by a double-wall construction with 20 inches of earth between and the 6-inch concrete ceiling covered with 20 inches of grass. Third, the tree-shaped metal shelter made from tree-shaped corrugated metal sections or pre-cast concrete can be constructed either underground or above ground. This shelter is also suitable for regions where rock or water are close to the surface. When covered with 3 feet of earth and given a protected entrance, it also will provide almost absolute protection. The cost, like the double-wall shelter, is about $700 plus the fee of a contractor, who probably would be needed to build. Number 4, the underground concrete shelter can be built by a contractor for about $1,000 to $1,500, depending upon the type of entrance used. Plans are designed so that it can have either a stairway entrance, such as is shown here, or with a hatchway. The shelter can be built with the roof at ground level and mounded over with earth, or it can be built below ground level or into an embankment. Last, the concrete basement shelter is similar to the underground concrete shelter, except that it is designed as an added room to the basement, either in an existing home or one under construction. The shelter would add about $500 to the cost of the shelter and would excellent fallout protection. In construction of any one of these shelters, 4 essential features must be completed. The first is a proper entrance. It must have at least one right-angled turn. Radiation travels in straight lines, only a fraction of it is scattered by the air or materials it strikes. So the sharp turn adds to the field. The second necessity is ventilation. This is provided in a concrete block basement shelter by vents in the wall with open entrances. The blower may be installed for added comfort. For the other shelters, vent pipe and the blower is essential for proper ventilation. Good radio reception is the next necessity. The shielding will cut it down. As soon as the shelter is completed, check the radio reception capability. It probably will be necessary to install an outside antenna to receive the tunnel broadcast. Lights with gas lines. The Civil Defense Shelter booklet will show him how to fix a simple electrical system. This will furnish adequate low-level light if you have a spare battery. You will also want a flashlight or electric lantern for brighter light as needed. After your shelter is finished, you should stock it with the provisions and equipment you will need for a 2-week stay. Since radiation outside may keep everyone inside, it is important that you have adequate supplies in your shelter. In choosing the building, place the emphasis on those which require no refrigeration and little cooking. Foods in cans or jars will stay in good condition 6 or more months, if kept dry, temperature between freezing and 70 degrees Fahrenheit. Goods in paper boxes may be kept for 6 months if they are stored in tightly closed metal cans under the same dry, moderate temperature. Ensure they are in a spot where rodents and insects won't attack them. Plan meals so there will be no leftovers, thus eliminating the problem of rapid sourcing. Meat, poultry, fish, vegetables, fruit, and many other items can be purchased in suitable quantities for such plans. Rotate canned foods at least once or twice a week. Change those in unprotected paper boxes at least every 3 months. Don't forget food for infants, elderly persons, diabetics, and others who might require special diet. Be sure that you choose food that fits the preferences of your family. Civil defense officials have sample menus showing the quantity of food that is set aside for each person and feeding them. Use this as your guide. Water will also be an important quantity. You will need a minimum of 1/2 gallon per day per person. It should be stored in clean containers, preferably jugs, bottles, or jars, tight-fitting cups. Water in the hot water will also be used to stay close to the shelter. Containers should be cleaned and refilled once every 3 months to keep the water powered. Water purification tablets should be on hand to treat water which might contain the minimum of oxygen. A battery-powered radio is essential to provide communication with the outside world. Store extra batteries rise and check the reception periodically. Sure you can receive Conolad broadcast. For cold weather, you will want lots of heavy clothing and warm bedding. In any weather, you will want some changes of clothing for all members of the family. A first aid kit will be very important. Your civil defense officials have a list of the basic first aid items like this. You should also have a 2-week supply of special medicines and equipment for the sick or chronically ill. Such things as insulin and hypodermic needles for diabetics. If you have a baby, remember to include powdered formula, canned milk, bottles, nipples, and disposable diapers, pins, towels, and so on. Provide sanitation supplies such as cans, tight-fitting lids for human waste and garbage, and a receptacle that can be used for storage. Don't forget essentials, towels, toiletry paper, sanitary napkins, and soap. A 5% DDT solution will protect you from waste. Remember how hard it is to keep children entertained on a rainy day? Maintaining a high morale in your shelter areas will be even more difficult because of transporters and monotonous surroundings. Appropriate religious articles, books, games, and other amusements. You will also want miscellaneous calendars, clocks, and candles. Screwdrivers, rubber gloves, and a shovel also may come in handy. More information on supplies and equipment, together with information on the approved fallout shelter, is contained in this book. Use it as your guide in planning and stocking your shelter. Now let's suppose for a moment that you can't get to the shelter in an emergency. What can you do to protect yourself? First, look for a base point. One below ground level will cut radiation to 1/10 of the level outside. The safest spot is in a corner which is least exposed to windows, deepest below the ground. If there is adequate warning, you can improve a basement's protection substantially by blocking the windows with bricks, dirt, books, magazines, or other heavy materials. If you are in a house with no basement, the best protection will be found in the ground floor in the central part of the house. The radiation there will be about half what it is outside. Large buildings such as apartment houses and office buildings afford excellent protection. With their thick walls and heavy floors, they provide almost as much shielding as concrete block shelter recommended for residents. If you have recently used such fallout particles on your person or clothes, they thoroughly leave the water outside the place. Outer garments also should be left outside, washed thoroughly before washing of clothes soon waterproof gloves with water. Fallout may be the primary threat which faces us in a national emergency. Keep in mind that it is a manageable threat. The right moves now will protect you and your loved ones later. You will need a good shelter and a 2-week supply of food and water and other living essentials. You have them ready to learn and keep safely apart. You and your family stand a first-rate chance of surviving any nuclear attack. Talk to your local or state civil defense officials immediately. They will give you detailed instructions on what you need to do. Then do it. Then you can rest assured that no matter what the fallout threat in the future, you and your family will be ready for it.
and what to do to protect yourself against it. Everybody needs to know. Yes, this does mean you. Watch and listen. One day, these facts may save your life. What is this fallout, anyhow? Just bits of radioactive fall out of the mushroom cloud of the nuclear explosion and settle on the ground. These bits of matter can be dangerous. You're exposed to some radiation every day, from cosmic rays or other natural sources of radiation. These exposures are too small to hurt you. But when a wartime nuclear explosion occurs, a serious fallout follows. Thousands of tons of atomized earth, building materials, rocks, and gases may be thrown into the air. The mushroom cloud containing them sometimes moves as high as 100,000 feet, nearly 20 miles up. Some of the radioactive particles spill out near the explosion site. Others may be carried for 10, 50, 100 miles or more. But how will you know if there is fallout? You can't hear, smell, taste, or see the radiation. But you yourself can detect the fallout particles that produce it. The easiest time to do this, without special instruments, is when the fallout is settling through the air. This starts any time from about 1/2 hour to several hours after the explosion, depending on how far away you are. And it continues to fall for an hour or longer. Usually you can see the fallout. So if there has been an explosion of a nuclear weapon within a few hundred miles of you, you should suspect every unusual concentration of dust in the air of being fallout. After an explosion in daylight, watch any unusual accumulation of dust. At night, put a white or light-colored plate outside. Examine it every 15 minutes or so. If dust is accumulated on the plate, treat it as fallout. The particles in that fallout behave like miniature X-ray machines, sending out radiation in all directions. There are many particles, and if you are exposed to them long enough, you will be hurt. Others will be watching for that fallout, of course. Experts will estimate the probable path and speed of approaching fallout and try to keep you posted. But it may come before you hear any details by radio or otherwise. You must take precautions, whether you hear their report or not. If radio stations are operating, you will hear reports, especially on the Conelrad frequencies 640 or 1240 on your AM dial. As soon as it is safe for specially protected crews to get out into the open, these highly trained civil defense radiation detection teams will make a thorough check of radiation levels and characteristics. Those facts will be relayed to you by radio as fast as they come into civil defense headquarters in your area. Information from the radiation monitoring team will be combined and analyzed by experts manning a central radiation control point. These experts, who know just how fast harmful radiation reduces in force, can predict when it will be safe for people to come out of shelters and resume normal tasks. We have warned that you may have to act before you get any detailed report. Just what can you do if fallout comes your way? Find the best shelter you can. The more solid substance you can put between yourself and the fallout, the better. But an ordinary frame house with windows closed will give considerable protection. In a house, it's best to get on the floor, away from doors and windows. Or if you can, find a location with additional walls in the center of the building. A basement is even better if the house has one. Large buildings, such as apartment or office buildings, give good protection. The thick, heavy masonry of their walls and floors makes it hard for radiation to get through. Basements, inside rooms, or corridors on the lower floors are safest. The basement of any house or building will become a good improvised shelter if you block the windows with sandbags and place other sandbags on the floor above the shelter area. If you don't have sandbags, thick, solid layers of books, magazines, or newspapers, or even a series of file cabinets standing close to each other can cut the radiation danger. In some parts of the country, there are storm cellars or outside vegetable storage cellars. They may be used as shelters from fallout. If you plan to use such a cellar, or your basement, or any other shelter, stock it with food and supplies. To equip and supply your shelter area, you need some of the same things you might take on a vacation camping trip. First, sleeping equipment to fit your shelter area. Folding cots, or sleeping bags and blankets. Then, food and water. There should be at least a 2-week supply. You'll want plenty of fruit juices and lots of your family's favorite canned food. The drinking water supply should be rotated often to be sure it's fresh. And don't forget such basic needs as sugar, salt, pepper, and other seasoning that your family ordinarily uses. Now, some equipment. A radio is very important. It should be a battery portable with spare batteries. A transistorized radio is best. The batteries last longer. Next, you need light in the form of flashlights and a battery-operated lantern. Then, a good first aid kit. Now, plates, cups, silverware. A can opener and a bottle opener are important. Add to these things enough closed containers to take care of garbage and human waste. Especially if there will be children in the shelter, include some books and magazines, paper and pencils, maybe 1 or 2 small, simple games. The best protection of all is the special shelter built according to specifications of your local civil defense organization. This has an air filter to allow ventilation, but keep dust out. It has at least 3 feet of earth over it. It would be a good idea to go right now to your local civil defense office to secure plans for the type of shelter you want, and then to get busy on construction. Plans are simple, using standard materials, so maybe you can do the job yourself. But all this special shelter talk won't help very much if you are caught way out on the open road. If that happens, keep driving until you see a building. It may be a house or barn, church or school. Drive as close to the building as you can. Then get yourself and your family out of the car and take cover in the building. If you live on a farm and have sufficient warning, get your animals under cover and give them enough food and water to last several days. And if you can, cover any piles of hay or harvested crops that may be outside. If the explosion has been some miles away, you will have time to fill tubs and other containers with water before fallout arrives. All locations where outside dust does not penetrate will be safe storage points for water. Whatever kind of shelter you find, settle down and make the best of it. If there are others with you, help them by being as calm as you can, and don't be discouraged. You can go out for very brief periods if you are well covered and keep the dust off your skin. Wear heavy boots or shoes, and pants tucked in or tied around the bottom to keep dust out. If any dust gets on you, brush it off promptly. When you have a chance, wash it off. That dust can burn your skin. But what happens if you do get exposed to a great deal of fallout? Food or water has been contaminated by the dust. Internal damage may occur. When dust has been left on skin, there will be skin burn. When you have been near dust too long, there may be radiation sickness. Exposure can even cause death. If you have had considerable exposure, you will vomit and grow weak. But after a few hours, this sensation will pass. And by the next day, you may have had the last of it. Even if you have been exposed to excessive fallout, you may eat and drink just as you normally would. But don't force yourself. Whether you have had these symptoms or not, if Civil Defense radio announcements have said that radiation has been high in your section, keep an eye on your condition for the next few days. Watch especially for these developments in the 2 weeks following exposure. Return of nausea, sore throat, bruise spots developing without any known reason, loss of hair. These conditions, or nosebleed, or diarrhea, should be reported to a doctor or to the nearest first aid station set up under civil defense plans. Unless civil defense teams have warned that your area is still dangerously radioactive, you can get out and work to help yourself and help others. Although fallout can be deadly, your chances of avoiding damage from it are much better if you follow the directions we have given you. During an alert, keep your portable radio tuned to the Conelrad radio frequencies, 640 and 1240 on the AM dial, for the latest reports and advice. Right now, today, before there is an alert, take time to learn the Civil Defense 5 steps to safety. Learn warning signals and what they mean. Learn your community plan for emergency action. Learn protection from radioactive fallout. Learn first aid and home emergency preparedness steps. And learn how to use Conelrad 640 or 1240 on the AM dial for official directions.
Since the beginning of history, lonely men have searched for a pot of gold under a distant rainbow. Now the prospectors have become, in a sense, a science. Now the object of the search is not only gold, silver, and copper, but also uranium, radioactive metal which signifies its presence by the reading on a Geiger counter. Foresee that in future years, uranium may supply power to heat our homes, drive our cities, and engineers' dreams of future reality. Today, blueprint for atomic power will require years to develop and apply. But atomic energy has still another aspect. The nuclear reactor
Incubator of plutonium, precursor of the atomic power plant of the future, is also the source of radioactive materials known as radioisotopes, available now as peacetime weapons in the continuing struggle for health, material satisfaction, and scientific progress. The radioisotope is probably the most important new means of perception and investigation. The invention of the microscope. To use this new means of perception, the scientist has been forced to acquire many novel techniques, absorb a variety of concepts and fundamentals. Radioisotope becomes useful to the scientist only when these concepts have taken their places in an orderly structure of method and underlying theory. The first concepts the scientist faces are those which have to do with the nature of matter and the dynamics of its smaller components. Now, it is known that the atom, long considered the basic unit of matter, is itself a void, in which planetary particles called electrons revolve in great orbits around a central nucleus. The nucleus also has a structure. It is composed of protons and neutrons. Each proton has a weight of 1.00758 atomic mass. The neutron is slightly heavier. In the usual notation, the mass is shown in round numbers, 1 for both proton and neutron. The proton carries 1 unit of positive charge, indicated in subscript. The neutron has no charge. The electron has 1 unit of negative charge. Its mass is insignificant compared to that of a proton or neutron. Again, charge is shown in subscript, mass in superscript. In describing an atom, the same notation is followed. The atomic number of the element, in subscript, is equal to the number of electrical charges carried by the protons in the nucleus. The mass number in superscript is equal to the sum of protons and neutrons. For instance, the designation for helium is 2 helium-4. Normally, the positive charge of the 2 protons in the nucleus is balanced by the negative charges of an equal number of orbital electrons. Atoms can be classified according to the number of protons in the nucleus, or the atomic number, and according to the number of neutrons. In terms of proton number and neutron number, it is possible to define any atom. Normal hydrogen atoms, for instance, have 1 proton and no neutrons. Helium, with 2 protons, usually has 2 neutrons. Lithium most often has 3 protons and 4 neutrons, and so forth. All the other atoms are identified according to the same system. The number of protons, or the atomic number, identifies the element. All atoms of the same element have the same number of protons. However, in most elements, there are found atoms of different neutron numbers. These different forms of the same element are isotopes, atoms of the same element, alike chemically, differing only in the number of neutrons. The sum of protons and neutrons gives the mass number. For instance, an atom of helium, which has 2 protons and 2 neutrons, has a mass of 4. A lithium atom, with 3 protons and 3 neutrons, has 6 mass units, and so on. Different isotopes of the same element have different mass numbers, since they have a different number of neutrons. Again, to complete the description of each atom, the element is accompanied by its atomic number in subscript. Most elements have 2 or more isotopes. However, a few have only 1. 57 has only one natural isotope. All cobalt atoms found in nature have the same atomic weight, 59. Therefore, the same number of neutrons. However, most elements have more than one natural form. For instance, zinc, number 30 on the chart, has 5 natural isotopes. In zinc, as in most elements, the number of neutrons is greater than the number of protons. The number of neutrons can be found by subtracting the proton number from the mass number. Higher on the chart, a few additional elements have only one isotope, though most have several. At higher atomic numbers, the ratio of neutrons to protons becomes greater and greater. In the natural isotopes of mercury, for instance, the lightest atoms have 116 neutrons, 36 more neutrons than protons. The heaviest have 124 neutrons, 44 more neutrons than protons. To illustrate neutron-proton ratio, the isotopes can be plotted on a graph of atomic number against neutron number. In this graph, a straight diagonal line would intersect all points at which proton number equals neutron number. However, if the isotopes found in nature are plotted on such a graph, it is found that they depart from the diagonal. In other words, they have a preponderance of neutrons over protons. A preponderance which tends to increase at higher atomic numbers. With a few exceptions, these positions represent atoms with stable neutron-proton ratios, capable of existing indefinitely without any observable change. The empty spaces represent neutron-proton ratios which would not be stable. It is reasonable to assume that if an atom existed in an empty space on the chart, it would show a tendency to change itself to an atom having a more stable neutron-proton ratio. For instance, an atom occupying a position above the natural isotope would have a disproportionately high ratio of protons to neutrons, and would tend toward the position of one of the naturally stable isotopes below it. Similarly, an atom having a disproportionate excess of neutrons over protons would tend to take a position of one of the naturally stable isotopes above it. This illustrates one of the primary principles of nuclear stability, the tendency of all atoms to reach an equilibrium in terms of a stable neutron-proton ratio. Up to atomic number 83, the natural isotopes are stable, with a few exceptions. However, above atomic number 83, all the isotopes are unstable. They all have a disproportionate number of neutrons, either too many or too few. Without exception, these isotopes are radioactive and return to stability through a process known as radioactive decay. For example, uranium, the heaviest element found in nature in significant amounts, has 3 natural isotopes. Each uranium isotope tends to return to stability through a series of transformations ending in a stable form of lead. An example of this process is the way in which uranium-238 changes to lead-206. The transformation from instability to stability is a complex process which takes place in a series of separate steps. First step occurs when the uranium atom throws off a nuclear particle of 4 mass units composed of 2 protons and 2 neutrons. This single unit is known as an alpha particle. In this change, uranium-238 atoms become thorium-234, which has 2 less units of charge and 4 less units of mass. The nucleus of the thorium atom emits an electron which possesses a negative unit of charge and negligible mass. This electron, thrown off by the nucleus of the thorium atom, is known as a beta particle. and is usually represented by the Greek letter beta. With this emission of a negatively charged beta particle, thorium-234 in turn changes to protoactinium-234, an atom with 91 charges instead of 90 on the nucleus. Protoactinium-234 throws off a beta particle, increasing atomic number by 1, thus changing to uranium-234. Uranium-234 next throws off an alpha particle to become thorium-230. In successive transformations, further alpha particles are given off, resulting in radium-226, radon-222, polonium-218, and finally lead-214, an unstable isotope. Two beta particles are emitted successively, producing bismuth-214 and polonium-214. Polonium-214 gives off another alpha particle to produce lead-210, still unstable. Again, one beta particle is emitted in each of two changes, to form polonium-210. With the emission of a final alpha particle, polonium-210 goes to lead-206, a stable isotope. Thus, in radioactive decay, a complex series of nuclear transformations has taken place from an unstable neutron-proton ratio to a stable state. In every step of radioactive decay, the transformation is from parent to daughter, and parent to daughter. Atoms of the parent element decay to produce atoms of a daughter element. The same terminology applies whether or not the transformation is to a higher or lower atomic number. There is no way of foretelling when any particular unstable nucleus will decay from one step to the next. However, in any sample of the radioactive isotope having millions of billions of atoms, some of the atoms are always in the process of decay. The number of atoms decaying in a unit time in a sample of radioactive isotope is called the activity of that sample. Activity, or rate of decay, is generally stated in terms of millicuries, or MC for short. A given sample of radioactive material is said to have an activity of 1 millicurie when 37 million atoms decay or disintegrate per second. The millicurie is the commonly accepted measure of radioactivity. Decay from a parent isotope to a daughter isotope can therefore be illustrated in terms of the number of unstable atoms and the time. On this graph, the number of unstable parent atoms that exist in any given instant can be represented by a point. Since the parent substance is decayed, fewer unstable parent atoms will be present at any later time. In the language of simple calculus, the number of parent atoms has decreased by delta n during a time interval delta t. The slope of the line between the 2 points corresponds to the rate of decay. The rate of decay, delta n over delta t, is proportional to n, the number of parent atoms present, or equal to minus lambda n. The minus sign indicates that n decreases with time. Lambda is called the decay constant and is characteristic of the particular parent radioisotope. If decay is plotted as a continuous series of short time intervals, an exponential formula is derived, which is the basic standard formula for radioactive decay. In this formula, n is the number of radioactive parent atoms present at a given time. N sub 0 is the number of radioactive parent atoms at the beginning of the first time interval. Is the base of the natural logarithm. Lambda, of course, is the decay constant of the parent substance. is proportional to the activity. The symbol N can be replaced by A throughout the formula. Accordingly, the same curve can equally well represent the change of activity rather than numbers versus time. From this equation for radioactive decay, activity at any moment can be determined in terms of the initial activity. In any decay process, there is a point in time at which activity is equal to 1/2 of that present initially. This time during which activity has decreased by half is known as the half-life. In successive half-lives, activity continues to decrease by successive halves, until finally only a small fraction of the original activity remains, since the decay rate for a specific radioisotope is usually given in terms of half-life. It is often convenient to substitute half-life for the decay constant lambda. The equivalent of lambda is 0.693 divided by half-life. This formula is often used in finding activity at any time t when half-life is known. Plotted in terms of the logarithm of activity against time, exponential decay is shown as a straight line. Figures for half-life are generally available in isotope literature. Each radioisotope has a specific half-life. The half-life may vary greatly, from a fraction of a second to thousands or billions of years. For instance, one isotope of cadmium has a half-life of 2.3 days. While carbon-14 decays to its daughter nitrogen after a half-life of roughly 5,700 years. Or take the case of uranium. U-238 has a half-life of 4.5 billion years, giving a straight line on a graph calibrated in terms of days. In contrast to the long half-life of U-238, thorium-234, the daughter of U-238, has a half-life of 24.1 days. Thus, while all steps of decay are unpredictable in a single atom, the statistical rate of decay in a large number of atoms can be predicted and measured with great accuracy. Examining the various steps in the decay series beginning with U-238, it appears that there are at least two ways in which unstable atoms can change to a more stable form. By throwing off an alpha particle and losing 4 units of mass and 2 electrical charges, or by throwing off a beta particle and increasing atomic number by 1. In the process of decay of U-238 to stable lead, each of the two types of transformation occurs several times. In 8 steps of decay, 8 alpha particles are given off. 6 beta particles are emitted. One would assume that these 14 particles would account for the mass difference between uranium-238 and lead-206. Let's check this assumption. The exact weight of an alpha particle is known from accurate determination. The 8 alpha particles thrown off weigh 32.022 units of mass. The mass of beta particles is also known with great accuracy. Adding the weight, it is found that 32.025 units of total mass have been given off as discrete particles during the decay process. But if the weight of lead-206 is subtracted from that of uranium-238, we find that the total mass lost in the decay is somewhat greater than that represented by the alpha and beta particles thrown off. In other words, 0.045 units of mass are unaccounted for, representing a minute fraction of a gram.
formula, it is found that this mass represents a really significant energy. In the transition from uranium to lead, this energy has been released in addition to the alpha and beta particles emitted. Most of this energy, released during uranium decay, has been applied in giving the ejected particles their high speed. In other words, as kinetic energy. Additional energy is also released as a form of electromagnetic energy known as gamma radiation. To summarize, the decay of uranium-238, resulting in stable lead, is accompanied by the release of alpha particles, beta particles, and gamma radiation. This is generally true. Change from instability to stability is accompanied by energy released as discrete particles or electromagnetic radiation, or both. It is the energy released by the decay of uranium in uranium-bearing ore which makes it possible to detect it with the Geiger counter, even though mixed in minute proportions with a variety of other substances. The decay period, beginning with uranium-238, is only one of several. A similar decay scheme begins with U-235, another with thorium-230, another with thorium-232. Uranium and all the unstable elements near it on the chart have very long half-lives, which have permitted them to survive from an early age of greater radioactivity. They are fated by the inevitable process of decay to return in time to a stable state. Lower on the scale of elements are found a few unstable survivors, naturally radioactive isotopes of long half-life, such as rhenium-187, Cesium-176, Tin-124, Rubidium-87, and Potassium-40. All of these return to stability in a single step. Potassium-40 offers a good illustration of the three possible modes of nuclear transformation. As one possibility, potassium-40 may give off a beta particle, increasing its nuclear charge by 1, and changing to calcium-40. In this case, the beta particle is accompanied by excess energy as a gamma ray. Or potassium-40 might emit a positive electron, reducing atomic numbers to become argon-40. The positive electron is known as a positron. As the third possibility, the potassium nucleus may absorb an electron, becoming argon-40 without emitting any discrete particles. In all three cases, there is a change in atomic numbers without any significant change in mass. The sum of neutrons plus protons remains the same. Obviously, each change must involve a shift in the neutron-proton ratio in the nucleus. For example, when potassium-40 changes to calcium-40, one of the neutrons in its nucleus has become a proton and an electron. In other words, a neutron of zero charge and one mass unit has become a proton of positive charge and mass 1, and an electron of one negative charge and very slight mass. Mass and charge units are conserved in the transition. When potassium-40 emits a positron and changes to argon-40, a proton in the nucleus has changed to form a neutron and a positron. This type of nuclear change is called positron decay. In the third possibility, one of the protons in the nucleus may join with an electron to form a neutron. This transformation would seem contrary to logic, since it is generally assumed that there are no free electrons in the nucleus. Such a phenomenon can best be explained by referring to the nucleus and its surrounding electrons. It sometimes occurs that an electron from the inner or K shell is captured by the nucleus and is immediately absorbed by a proton. The opposite electrical charges neutralize one another, and the proton becomes a neutron. This transformation is known as K electron capture. When it occurs, it causes a series of changes in the outer electron shell. First, the empty space in the K orbit is filled by an electron from an outer orbit. The empty space in the second orbit is filled by an electron from an orbit further out, and so forth. In this cascade of electrons from outer to inner orbit, X-rays are released, which represent the difference in potential energy between different electron shells of the daughter atom. The K X-ray, which corresponds to the energy released in capture of the K electron, represents most of the measurable energy released. Thus, when potassium-40 captures a K electron and changes to argon-40, the transformation is accompanied by the emission of X radiation. While a single atom of potassium-40 can decay in only one of three ways, with a large number of potassium-40 atoms present, some will decay in each way. Energy is released as positrons, beta particles, and gamma rays, and in K capture as X-rays. In potassium-40 decay, positron emission is difficult to substantiate, occurring rarely, if at all. In K capture, the X-rays emitted are of low energy and difficult to measure. In other radioisotopes, any of these radiations may be given off in different proportions and relative energy. Decay and emission of energy as radiation occur in all radioisotopes. However, uranium-235 and one or two other radioisotopes have a second and unique characteristic. If it were possible to observe a single atom of uranium-235 and to penetrate through the electron shells to the nucleus itself, it would appear to be in a constant state of agitation. In all probability, it would throw off an alpha particle as the first step in the decay process. However, in a gram of 235 each second, at least one atom decays quite differently. It becomes more and more unstable until it splits into two fragments, each a lighter atom of lower atomic number. In addition, two or more neutrons are left over from the reaction. This is the reaction of spontaneous fission. In a single fission, taking place in a minute fraction of a second, considerable energy is released, about 4 times as much in small steps of the long decay process of U-238 with stable lead. Part of the energy is kinetic energy, giving velocity to the neutrons in the two fragments of uranium. The remainder of the energy is given off as gamma radiation. And beta radiation. neutrons may strike and be absorbed by another nucleus of U-235. With the added mass, this nucleus in turn fissions, releasing still other neutrons as the process continues. This is a chain reaction, such as that which takes place in an uncontrolled manner in the atomic bomb. However, if uranium fission occurs in uranium mixed with some light substance such as graphite, the neutrons are slowed down by collision with the carbon atom. Because of its slowing action on the neutron, graphite or other light substance is known as a moderator. The neutrons, because of their reduced velocity, are much less likely to escape from the uranium and are much more likely to penetrate the nuclei of the uranium atom.
В соответствии с программой испытаний новых образцов водородных зарядов 30 октября 1961 года был произведен взрыв чистой водородной бомбы с тротиловым эквивалентом 50 миллионов тонн. Новый водородный заряд разработан большим коллективом ученых, конструкторов и изготовлен на предприятиях министерства. При испытаниях заряд был смонтирован в корпусе авиационной бомбы, способной вмещать заряды мощностью 100 миллионов тонн и более. Взрыв намечалось произвести на большой высоте над землей с использованием самолетом. В хвостовой части бомбы предусмотрено место для установки парашютного устройства. Для транспортировки в собранном виде изделие было помещено в особый железнодорожный вагон. Стенки и крыша вагона разборные. Место назначения изделие было направлено специальным поездом. При следовании поезда были приняты все необходимые меры безопасности. Для подготовки бомбы к испытаниям и подвески ее к самолету был выбран один из аэродромов дальней авиации военно-воздушных сил, расположенный на Кольском полуострове. Сюда прибыл поезд с изделием. На железнодорожной станции аэродрома хорошо оборудованная погрузо-разгрузочная площадка.
операции производились по намеченному заранее регламенту. После завершения разборки вагона к железнодорожному составу подан автомобильный поезд. Изделие было перегружено на автоприцеп для дальнейшей транспортировки. Проверка и подготовка изделия к испытанию производилась в специальном здании. Здесь детальному и строгому техническому контролю был подвергнут каждый узел изделия, каждый элемент его автоматики. В момент срабатывания заряда имеют значение даже миллионные доли секунды. Поэтому элементы автоматики, телеметрические датчики и передающие устройства должны быть настроены на заданную программу с абсолютной точностью. Проверка узлов изделия подходит к концу. Устанавливаются на свои места съемные части пола. Закрываются люки. Последний общий осмотр. Снова погрузка на автоприцеп. Бомба подготовлена для вывода на поверхность. Одновременно с подготовкой изделия производилась подготовка тяжелого бомбардировщика дальнего действия с узелом «Decay», способного нести бомбу весом 26 тонн. Весь корпус самолета и даже лопасти его винтов окрашивались особой защитной краской, предохраняющей от светового действия взрыва. Для определения теплового и ударного двигателя на самолет устанавливается измерительный прибор. Специально оборудованный самолет-лаборатория должен сопровождать самолет. На борту этого самолета были размещены приемная радиотелеметрическая аппаратура, самописцы давления ударной волны, осциллографы регистрации мощности взрыва по минимуму значения, аппаратура для записи показаний приборов на магнитном зеркале. Снаружи крепились кинокамеры для съемок явления взрыва в воздухе. Устанавливались калориметры для замера тепловых потоков. Узел связи аэродрома. Его сооружение радиотелефонного светофора. Автоматическая радиостанция – одна из самых мощных на севере нашей страны. Все это позволило организовать систему надежной, дублированной связи между пунктами, обеспечивающими проведение испытаний, которые находились на значительном расстоянии друг от друга. Государственный испытательный полигон номер 6 Министерства обороны СССР, на котором должен был производить бомбы, расположен на новой земле. Район Белушный, основная база полигона. Здесь размещается штаб научных подразделений, лаборатории и программы. На период испытаний в Белушной была сосредоточена группа судов морского обеспечения. Объединенный командный пункт руководства испытанием находился в подземном сооружении. Здесь большой радиотелеграфный и радиотелефонный вызов. Его задача входила поддерживать двустороннюю связь с пунктами, расположенными на территории полигона, с аэродромом на Польском полуострове, самолетом-носителем во время его полета. Расстояние от командного пункта в Белушью до опытного поля 250 километров. Значительно ближе находилась площадка Decay. От нее до опытного поля 90 километров. Эта площадка использовалась для подготовки и управления автоматической измерительной и регистрирующей аппаратурой, размещенной в районе взрыва. Средством сообщения между площадкой Т-8 и опытным полем служили военные корабли. Оперативные переброски производились на вертолетах. Площадка для сброса бомбы была выбрана в той части новой земли, где характер местности создавал наилучшие условия безопасности взрыва. Задача испытания не входила в изучение разрушительного действия ударной волны. Поэтому мы не видим в районе опытного поля специальных конфликтных зданий, а также какой-либо военной техники. Вместе с тем, здесь было размещено большое число самой разнообразной аппаратуры для регистрации и измерения параметров взрыва. В 20 километрах от центра площадки в наземных металлических сооружениях устанавливались фотокамеры. Киносъемочная и регистрирующая аппаратура. На расстоянии 2 километров в подземных сооружениях была размещена аппаратура, фиксирующая процесс развития ядерного взрыва. Осциллографы записью коэффициента размножения нейтронов. Измерители интервалов времени срабатывания автоматических устройств зарядов. Управление аппаратурой, установленной в сооружениях опытного поля, производилось автоматически по радио. Радиосигналы поступали с площадки Т-8, где в подземном сооружении находился командный пункт службы автоматики.
автомат, выдающий команды на поле. Как же проходил основной этап испытаний? До взрыва осталось несколько часов. Белушный, начальник штаба полигона, принимает доклад о мерах, принятых по выполнению оперативного плана морского обеспечения. В этом плане точно определено, где будут находиться корабли и личный состав полигона в момент взрыва. Подготовка опытного поля закончена. Производится полная эвакуация личного состава и кораблей в безопасные зоны. Напряженно работает метеорологическая служба. Составляется карта прогноза погоды. Особенно тщательно изучается направление ветров. В боевой готовности служба противовоздушной обороны. Опасный район покидает последний суда. Принято решение подвесить изделия самолету-носителю. Подвеска бомбы такого размера и веса не совсем обычное дело. Но на аэродроме к этому хорошо подготовились. Производится осмотр. Особенно тщательно проверяется укладка парашютной системы. От надежности ее работы зависит безопасность экипажа самолета. Для подвески бомбы созданы специальные подъемные устройства. Подъем изделия к самолету идет плавно и равномерно. Размеры бомбы не позволяют разместить ее в бомболюте самолета, поэтому она закрепляется снаружи под фюзеляжем. Заседание Государственной комиссии по проведению испытаний. Производится оценка общей обстановки, складывающейся в районе испытания к назначенному времени взрыва. Окончательно уточняется трасса и условия полета самолета-носителя. На новой земле еще раз проверяются условия безопасности от последствий взрыва для районов, расположенных вне территории испытательного полигона. Анализ данных, из которых складывается общая обстановка к моменту взрыва, дает уверенность в том, что распространение ударной волны будет ограничено, а зона возможных разрушений ледяной поверхности минимальна. Утро 30 октября. Носитель готов к старту. Последний инструктаж экипажа. Командный пункт аэродрома. Приближается время старта. Разрешен
запуск моторов. Заработали турбовинтовые двигатели. Лед разрешен. Следом за носителем в воздух поднимается самолет-лаборатория. Самолет-носитель с подвешенной к нему особо мощной водородной бомбой набирает высоту. За ним ведется неослабное наблюдение из различных пунктов на Земле. С экипажем поддерживается непрерывная двусторонняя связь. Десятки локационных станций противовоздушной обороны следят за общей обстановкой в космосе. Высота 10 500 метров. Экипаж самолета-носителя отлично подготовлен к выполнению ответственного боевого задания. На параллельном курсе самолет-лаборатория. Точно следуя намеченным курсом, самолеты приближаются к новой Земле. Теперь управление полетом и связь с самолетами передается командному пункту полигона. Сюда поступают доклады экипажей о ходе полета. Отсюда, по условным таблицам, передаются команды на самолет-носитель. Носитель вышел на боевой путь. Цель видна. Управление сбросом бомбы переводится на автоматику. Сигнал «Сброс». На D8 включается программный автомат аппаратуры опытного поля. «Сброс». Экипаж одевает защитные очки. Программный автомат принял сигнал «Сброс» и выдает команды запуска аппаратуры опытного поля. Точно по расчету сработала парашютная система. Бомба приближается к точке взрыва. Высота 4000 метров. Осталось 3 секунды. 2, 1, 0. Взрыв сопровождался световой вспышкой необычной силы. В этот момент самолет-носитель находился в 45 километрах от места сброса. Вспышка и последующее свечение, несмотря на сплошную облачность, были видны в радиусе до 1000 километров. Полевой столб, поднимающийся с земли, быстро увеличился в объеме. Через несколько секунд после взрыва диаметр полевого столба составлял около 10 километров. В это же время
самолета, находившегося в 250 километрах от точки взрыва, был виден огненный купол из раскаленных продуктов взрыва. Он медленно поднимался вверх, увеличиваясь в объеме. Максимальный диаметр купола доходил до 20 километров. Пронизав несколько слоев сплошной облачности, огненный купол через 40 секунд после взрыва достиг высоты 30 километров. С этого момента началось постепенное превращение купола в грибообразное облако. Увеличиваясь в размерах, облако медленно поднималось вверх. В своем конечном развитии оно достигло высоты 60-65 километров. Его диаметр равнялся 90 километров. В дальнейшем облако начало утрачивать грибообразную форму. В этот период диаметр его основания был равен 70 километрам, а диаметр ножки 26-28 километров. При возвращении на аэродром экипаж самолета-носителя наблюдал облаком взрыва на расстояние 800 километров. Через несколько часов после взрыва на опытное поле вылетел вертолет радиационной разведки. В район опытного поля вышли корабли с испытательскими группами. А вот и опытное поле. Перед посадкой вертолета проверка радиоактивности. Даже в самом центре площадки она оказалась незначительной. Испытательским группам полигона разрешен выезд в поле. Вспомним, как выглядело опытное поле до взрыва. Теперь его вид на десятки километров вокруг опаленная взрывом земля. Разбиты входы в подземные приборные сооружения. На основе даже самых предварительных данных стало очевидно, что произведенный взрыв является рекордным по своей силе. Вместе с тем выбранная высота и метеорологические условия в момент взрыва несколько раз уменьшили предполагаемую зону воздействия ударной волны. В эту зону входил ряд населенных пунктов. Ни в одном из них не было отмечено каких-либо существенных последствий взрыва. В то же время даже наиболее отдаленных от опытного поля пунктах были отчетливо видны вспышка взрыва, длительные свечения и был слышен звук пришедшей ударной волны. Вся регистрирующая измерительная аппаратура на опытном поле сработала нормально. Полученные данные позволили определить фактическую мощность взрыва, характер ядерной реакции, точность срабатывания автоматики изделия
и ряд других факторов. Испытание особо мощного водородного заряда, имеющего ряд новых конструктивных особенностей, подтвердило, что Советский Союз имеет в своем распоряжении термоядерное оружие мощностью 50, 100 и более мегатонн.
It's what we all must learn to do. You and you and you and you. Duck and cover.
Be sure and remember what Bert the Turtle just did, friends, because every one of us must remember to do the same thing. That's what this film is all about. Duck and cover.
This is an official civil defense film produced in cooperation with the Federal Civil Defense Administration and in consultation with the Safety Commission of the National Education Association.
Produced by Archer Productions, Incorporated. Hey, Bert, come on out and meet all these nice people, please. Oh, all right. We really can't blame you. You see, Bert is a very, very careful fellow. When there's danger, this is the way he keeps from being hurt. Sometimes it even saves his life. That's why these children are practicing to duck and cover just as you do in your school. We all know the atomic bomb is very dangerous. Since it may be used against us, we must get ready for it, just as we are ready for many other dangers that are around us all the time. Fire is a danger. It can burn whole buildings if someone is careless. But we are ready for fire. We have a fine fire department to put out the fire, and you have fire drills in your school so you know what to do. Automobiles can be dangerous too. They sometimes cause bad accidents, but we are ready. We have safety rules that car drivers and people who are walking must obey. Now, we must be ready for a new danger, the atomic bomb. First, you'll have to know what happens when an atomic bomb explodes. You will know when it comes. We hope it never comes, but we must get ready. It looks something like this. There is a bright flash, brighter than the sun, brighter than anything you've ever seen. If you are not ready, did not know what to do, it could hurt you in different ways. It could knock you down hard, or throw you against a tree or a wall. It is such a big explosion, it can smash in buildings and knock signboards over, and break windows all over town. But if you duck and cover, like Bert, you will be much safer. You know how bad sunburn can feel. The atomic bomb flash could burn you worse than a terrible sunburn, especially where you're not covered. Now, you and I don't have shells to crawl into like Bert the Turtle, so we have to cover up in our own way. First, you duck. Then, you cover. And very tightly, you cover the back of your neck, your face. Duck and cover underneath a table or desk or anything else close by. In Betty's school, they are talking about the atomic bomb too. Betty is asking the teacher, how can we tell when the atomic bomb may explode? And the teacher is explaining that there are two kinds of attacks, with warning and without any warning. We think that most of the time we will be warned before the bomb explodes, so there will be time for us to get into our homes, schools, or some other safe place. Our civil defense workers, our men in uniform, will do everything they can to warn us before enemy planes can bring a bomb near us. You may be in your schoolyard playing when the signal comes. That signal means to stop whatever you are doing and get to the nearest safe place fast. Always remember, the flash of an atomic bomb can come at any time, no matter where you may be. You might be out playing at home when the warning comes. Then be sure to get into the house fast, where your parents have fixed a safe place for you to go. If you are not close to home when you hear the warning, go to the nearest safe cover. Know where you are to go, or ask an older person to help you. You know the places marked with the S sign? They're safe places to go when you hear the alarm. If there is a warning, you will hear it before the bomb explodes. But sometimes, and this is very, very important, sometimes the bomb might explode without any warning. Then the first thing we would know about it would be the flash. That means duck and cover fast, wherever you are. There's no time to look around or wait. Be like Bert. When there is a flash, duck and cover, and do it fast. Here are some older boys showing what to do if the flash comes when you are not in the flash. This is what you do to be in a corridor. You duck and cover tight against the wall this way. Remember to keep your face, the back of your neck, covered tightly. try to fall away from windows or doors with glass in it. Then, if the glass breaks and flies through the air, it won't cut you. You might be eating your lunch when the flash comes. Duck and cover under the table. And then, if the explosion makes anything in the room fall down, it can't fall on you. Getting ready means we will all have to be able to take care of ourselves. The bomb might explode when there are no grown-ups there. Paul and Patty know this, and they're always ready to take care of themselves. Here they are on their way to school on a beautiful spring day. But no matter where they go or what they do, they always try to remember what to do if the atom bomb explodes right then. It's a bomb. Duck and cover. Paul and Patty know what to do. Paul covered the back of his head so that he wouldn't be burned, and Patty covered herself with the coat she was carrying. They knew how to duck and cover. They acted right away when the flash came. If they had been at this doorway when the bomb flashed, Paul and Patty would have ducked and covered this way, like this girl. Heavy doorways are a good place to duck and cover. G will be safer, too. Here's Tony going to his Cub Scout meeting. Tony knows the bomb can explode any time of the year, day or night. Get ready for it. Duck and cover. Atta boy, Tony. That flash means act fast. Tony knows that it helps to get to any kind of cover. This wall was close by, so that's where he ducked and covered. Tony knew what to do. Notice how he keeps from moving or from getting up and running? He stays down until he is sure the danger is over. The man helping Tony is a civil defense worker. His job is to help protect us when there is danger of the atomic bomb. We must obey the civil defense worker. We must know how to duck and cover in the school bus or in any other bus or streetcar. Duck and cover. Don't wait. Duck away from the windows fast. The glass may break and fly through the air and cut you. Sundays, holidays, vacation time, we must be ready every day, all the time, to do the right thing if the atomic bomb explodes. Duck and cover. This family knows what to do. Your own family should. They know that even a thin cloth helps protect them. Even a newspaper can save you from a bad burn. But the most important thing of all is to duck and cover yourself, especially where your clothes do not cover you. No matter where we live, the city or the country, we must be ready all the time for the atomic bomb. Duck and cover. That's the first thing to do, duck and cover. The next important thing to do after that is to stay covered until the danger is over. Yes, we must all get ready now, so we know how to save ourselves if the atomic bomb ever explodes near us. If you do not know just what to do, ask your teacher when it's filmed over. Discuss what you could do in different places if the bomb explodes. Older people will help us as they always do. There might not be any grown-ups around when the bomb explodes. Then, you're on your own.
Remember what to do, friends. Now tell me right out loud. What are you supposed to do when you see the flash? Duck and cover. Duck and cover. Duck.
Outside the town of Las Vegas, at Nellis Air Force Base, a series of events took place. Events not included in routine airfield operations. The 280-millimeter guns were taken off their railroad flat cars and started on the 65-mile journey provide the proof of their atomic might. On their way through Las Vegas, the big guns experienced no trouble whatsoever in negotiating the city. On the sharpest of turns, however, was where they really proved their mettle. Handled exactly like the biggest hook and ladder trucks of any fire department, but some 30 feet longer and many tons heavier, the guns took every twist and turn in stride. They are big, but flexible. Once out of Las Vegas, they settled down to the long grind north to the proving ground. During field operations involving the 280-millimeter gun, they travel in batteries, such as these. A battery consists of 2 guns. 3 batteries make up a battalion. The battalions provide support for field army or separate corps action. There are, with each battery, 9 support vehicles, acting as transport for gun personnel, supplies, and ammunition. In convoy on the hard-top highways, the guns can travel at 30 miles per hour, and in spite of their road weight of 76 tons, can use the standard Army bridges wherever necessary. 70 miles north of Las Vegas was the turnoff to the firing site. In 1944, when the original design specifications were drawn up, the gun was to have been a 240-millimeter weapon. However, these specifications were soon changed for the rapidly advancing artillery capabilities and the foreshadowing of the atomic age. Instead, were substituted the designs for a 280-millimeter weapon, with not only HE, but atomic firepower. In 1951, the gun was tested as a normal artillery piece at Aberdeen. Needless to say, these tests were successful. All that remained was to check out its other capabilities, the atomic shell. Even on secondary roads or rough terrain, the guns retain relatively high mobility in spite of the fact that their speeds are lowered to approximately 10 miles per hour. The main reason for this mobility are the prime movers connected to the front and the rear of each weapon. Each prime mover is capable of 365 horsepower. Just one of these cabs has 50% more payload than the largest Western highway truck. For a heavyweight fighter, the big guns are light on their toes. Once at the firing site, the line of fire was given, and the guns were directed to their respective emplacements. After getting into position, the rear cab lowers the gun and moves away. Then the front cab winches the tube into battery and moves away. Unlike field operations of World War II, these guns need no extensive ground preparation. In most cases, there is no necessity for excavation of any kind. The entire 47-ton weight of the gun itself is balanced by a turntable and 3 jacks to hairbreadth specifications. For the total time to prepare for firing, just 20 minutes. After being emplaced in their firing positions, and prior to the firing of the Mark 9 atomic shell, a series of HE rounds were fired. These rounds serve the purpose of a final check on the many ballistic variables which could affect the accuracy in a given situation. Unlike the standard artillery weapons, which are single recoil mechanisms, the 280-millimeter gun has the advantage of a double recoil action. when fired, the tube recoils into the upper carriage, and then the upper carriage recoils. Such a system is the main reason for the lack of ground preparation needed before firing. A folding trough is used to load the projectile and the propeller. During firing operations, ramming can be done both manually and hydraulically. The gun is capable of a 360-degree traverse and can go to a maximum elevation of 55 degrees. The time for rehearsals and final checkout is over now as 0 hour approaches. The big gun is ready to prove its atomic punch with the firing of the Mark 9 shell as one phase of Operation Upshot Knothole in the Nevada desert. Everything functions with a precision found in any capable, well-trained team. 0 hour is minutes away now. The projectile is prepared and brought to the gun. The final correct setting for time of burst is made. The breech closed and the primer inserted. Once loaded, the gun's elevation is set with a gunner's quadrant. Sighting is done with a panoramic telescope. As the last step, the primer is connected and continuity of timing and firing circuits is completed between the control point and the firing site. With everything set now, the gun crew moves back to take positions in flip benches during firing. The time is 08:30. The date, 25 May, 1953.
4, 3, 2, 1.
With a degree of accuracy 4 times greater than any gun developed before World War II, the 280mm gun has proven its worth. Capable of delivering the atomic shell some 13 miles under any weather conditions, day or night, the big gun provides more accurate and damaging support to ground troops than any other gun in the recorded history of warfare. Exceedingly powerful, but flexible, and with a high degree of mobility, the 280mm gun is one of the Army Field Force's newest tactical weapons.
great teachers, great leaders, great commanders, and great under the leadership of Chairman Mao, the founding Communist Party, under the guidance of the general line of socialist instruction of the party to strive hard and strive to advance, and to get greater, faster, better, and more economical results, and under the three great movements of class struggle, production struggle, and scientific testing, our Chinese people have achieved great successes. Our nation's people's communes are further developing and consolidating. In the wide countryside, there is revolutionary outlook everywhere, and there is laughter everywhere at the cause of public progress. They say we must turn globalization on a large scale, and have the courage to do this on a large scale. Gather the red flowers which are blooming everywhere on a large scale. The broad masses of workers on the industrial war front are fiercely engaged in revolutionization and fiercely breaking loose from foreignization to choose their own industrial development. They are applying this spirit of applying maximum effort is prevalent throughout the whole nation. Throughout our great fatherland, the heat of revolution is generating everywhere, and a new all-around leap-forward situation is emerging. Our national defense industry, under the correct leadership of the Party's Central Committee, the great leadership of Chairman Mao, Comrade Bauer, the Coast War Buddy of Chairman Mao, and Comrade Joe and Lai, is progressing at 1,000 li a day. Preparations for our nation's first nuclear tests are intensely underway. Mao Zedong's launch guide us in all our work. In response to Vice Chairman Lin Bao's call, the comrades raise high the great red flag of Mao Zedong's ideology, creatively study and apply Chairman Mao's work, and apply themselves vigorously. It's the hottest time in the day to march in boiling sand. In each training session, how much sweat do they perspire? During the intense struggle, they always maintained the glorious traditions of our army, resolutely struggling in spite of hardship and displaying the cheerful revolutionary spirit. Comrades of the cultural and art groups penetrate deeply into the area to conduct propaganda and stimulating activities. The comrades, using discarded lumber to make poles, grass fields to reset, engage in mass physical exercise. In the whole camp area, the atmosphere is enveloped with a spirit of unity, faith, solemnity, and animation. Western Front. This is a gigantic success of the general line. Long live the Chinese Communist Party. Long live Chairman Mao. Personnel and cars entering the contaminated area of the explosion for recovery work are given strict examination. These women comrades are glad to join the ranks of combat. Chairman Mao says, in all work, we must be enthusiastic but calm, and intense but orderly. See how intensely and earnestly they attend to their work. Announces the news about our nation's successful experiment in testing its first atomic bomb. The nuclear monopoly, nuclear tyranny of the U.S. imperialists and the revisionists have been thoroughly bankrupt. Their criminal attempts to block and prevent our nation's people from grasping nuclear weapons have been thoroughly smashed. Work for the second nuclear test is begun. The comrades, not fearing hard labor and fatigue and continual fighting, are eagerly engaged the greater the power is, the more intense the close fighting and night fighting will be. Regardless of offensive or defensive, the final decisive battle will be one of close combat at 100 or 200 meters. At that time, it will depend on who is tougher, who can hold the position, who can hold it, who dares to see red on his bed. At that time, it will depend on one's proletarian consciousness and one's pulse. We have the spiritual atomic bomb, which is impossible for the enemy to acquire, and we also have the material atomic bomb. No enemy can defeat it. If the imperialists dare to impose war on our heads, we will render and thoroughly and completely destroy all of it.
Radioactive.